on this computer. And I think that we will start with Nissim first. No, Nissim, or you? You are muted.
If you will allow me to share my screen.
Yeah, I mean, I think that already this option has been provided.
Okay. Hey, good morning, everyone. Yes, we will start with our first session now in this workshop. I think this day is more focused on students, but I think this mix is very good to be students and teachers together and to think how to learn mathematics. The first part will take Nissim Harel. He is from the Holon University in Institute of Technology in Israel. And I think the second part of this session will take Konstantinos Petridis from the Hellenic Mediterranean University, our chief here, our leader of this project. We are very happy to work with you and thank you very much for this lot of work you have done to organize this 2 days workshop. Okay, Nissim, if you are ready.
Thank you very much, Renate.
Yeah.
Thank you.
Thank you to be here, Nissim.
I will talk about strategies to learn math, how to learn math, and the reason why we need these strategies is because most of the students studying for a science and engineering or a computer science degree do not seem to like studying mathematics. They underappreciate the importance and the role of that mathematics plays in solving real-life problems and applications. Usually they remember the math studies in high school as an endless series of technical drills. They recall the stress that accompanied math studies when everybody told them that math is an important subject that is crucial to their success. And to be honest, I was no different. When I was a child, my father used to tell me that there is only one subject that is most important to study at school, only one, mathematics and English. Of course, I believed and internalized what I was told, and frankly, apart from repeating the slogans that I heard, I could hardly explain to myself, let alone to others, why these claims are true, how this very difficult subject is connected to my future success. Mathematics studies seemed to me then, and I feel they seem to many students today, as a hurdle one must pass in order to succeed. Very much like a visit to the dentist, but unfortunately it takes much, much longer than a visit to the dentist. The reason why I was happy when Dr. Petridis asked me to give this talk is that today, me and my colleagues to the ITEM project no longer share this view. We think that math doesn't necessarily have to be a hard subject, and it can be interesting and engaging. The purpose of this talk is to help you succeed in your math studies. I hope to demonstrate to you how important are mathematics studies to your professional success in any science and engineering subject. And I hope to provide you with methodologies and tips that will help you to learn math more efficiently. So first of all, I would like to start by showing the first year courses in the computer science department at the higher education institution I teach. Although there are variations among different higher education institutions and among different departments and faculties, there is one thing in common to all of them, which is a strong emphasis on mathematics studies. If you are learning any science or engineering subject, you are bound to spend a lot of time studying math. Before we delve into ways to tackle this challenge, we ought to spend some time understanding why this is the case, why students spend so much time on mathematics studies, and why math is so important. So the thing is that math is a common language and an efficient efficient way to model the world. A mathematical model can describe and even explain observed phenomena. It helps solve complex problems and predict what is going to happen in the future. Crucial for engineering, math studies provide background to your elective courses. Without them, it will be hard for you to get the best out of these classes that you will learn in the second and third year of your studies. And I would like to start with a few examples for the use of mathematics in electrical engineering and computer science. And of course, I can find many other examples in other disciplines. First, if we look at the signal processing, that is speech recognition or image processing, medical imaging, they rely on calculus, linear algebra. They use methods like Fourier transforms, convolutions, and inner products. Algorithms in machine learning and deep learning, neural networks rely on linear algebra, calculus, and statistics, and they use methods such as finding a minimum of a function, matrix multiplication, inner products, Bayes laws. Algorithms in communication rely on graph theory to calculate the best possible path for a unit of information to reach from the source to the destination. Cryptographers develop and break ciphers using abstract algebra, number theory, and probability. So we find mathematics in every field of science and engineering. The mathematical language itself consists of a syntax. For example, how to write a formula. Semantics, what the formula means. For example, E equals mc squares. Mc square connects between energy, mass, and the speed of light. You can see here a formula for calculating the gravitational force between two objects. This is what the formula means. And using inference rules, we can write mathematical proofs and establish new conclusions based on prior knowledge. So math is a very important tool for scientists and engineers. The thing is that the method of study in higher education, this is one of the reasons why it is so difficult. The method of study in higher education is very different from the way we study mathematics in high school. I will demonstrate the difference using the concept of a linear function and the way we learn it in high school. So in high school, a concept such as linear function is defined, and the method of definition was from individual to gradual. And I would like to demonstrate that. At the beginning, when the subject is being introduced, we see many examples of linear functions, such as y equals 2x plus 5, g equals cx plus 1, h equals 8x, and so on. From the examples, we practice them, and from the examples, we realize that a linear function is a function of the following structure. Fx equals ax plus b, where a and b can be any real numbers. And then we see some examples in graphs and so on. And only after we have the definitions, we begin to, the teacher explains features related to a linear function, such as the number b is the value on the y-axis where the function intercepts the axis. So this is how we learn things in high school. But in higher education, the method is totally different. There is a separation of study materials between lectures and recitations. As part of the lecture, the student learns the overall theoretical material, definitions, attributes, statements, statements that can be proved, which means that these are new insights that are necessarily true based off the knowledge we have acquired before, and very few examples. As part of the recitation classes, the student is exposed to a practice which presents problems that can be solved by the tools that were taught in the lecture. I will demonstrate by taking an example from calculus and the definition of a polynomial. A polynomial with a single intermediate x can always be written in the form of px equals an multiplied by xn plus an minus 1, x to the power of n minus 1, and so on and so forth until a0, where x is the intermediate and an to a0 are the constants. Then after the lecturer shows what a polynomial is, then the lecturer provides an example, for example, px equals 5x plus 9, and immediately proceeds to the next theorem. So what we have is a very fast pace, and due to the very fast pace of the study, not all the definitions and proofs that are taught in one lecture can be internalized. And therefore, you need to go over the material after the lecture, preferably even before the recitation class, in order to better understand the methods for solving problems. In fact, the fast pace of learning in higher education assumes that for every hour of study in the class, you spend at least 1 or 2 hours reciting the material at home. And I will show you later what does it mean and how you recite the material at home and what to do. So what we have in the academia is a fast learning pace. And one lecture requires at least 1 or 2 hours of independent study. And the result is that if we're not working well, from time to time, we may lose the lecturer during the lecture and feel we don't understand the material. And this is no reason to be despaired. First of all, some of the topics will be explained later, and maybe you will have an opportunity to understand them better later. But really, there is a little chance that you will always understand everything immediately in the lecture, just because of the fast pace and the amount of material that is being taught during the lecture. So going over the material memorization and adopting the learning strategies that I will elaborate on soon will give you tools to succeed in learning at the required pace. So first of all, I would like to propose 1 or 2 strategies and then a methodology. So one of the most recommended learning strategy is learning in pairs. And pair learning is learning together with another student. It was hard during the COVID-19 pandemic, but this methodology has proven to be very effective learning methods. Why? First, because meeting times are set in advance. And therefore, there is a higher likelihood that learning after class hours will actually take place. If we study alone, we can procrastinate and so on. Furthermore, the kind of encounter requires you to go over the material. One of the biggest advantages of pair learning is that there is a mutual relationship between 2 students. The student who is more proficient in the study material serves the role of the instructor who teaches through and answers his friends' questions, and therefore internalize the material. Through these questions, one of the students plays the role of the instructor, and one of the and that way he or she understand the material better, and the friend questions help the friend um, internalize the material. Of course, the learner learns better through this explanation and saves time, because the learner doesn't have to spend a lot of hours trying to crack the difficulties. And of course, these roles are not set, are not fixed. The two students can change the roles depending on their level of understanding of the material that is being taught. So pair learning is highly recommended. The other thing is that we all have a tendency to procrastinate and to leave the study to a time close to the exam. And unfortunately, this is a recipe for failure. Courses are built on evolving knowledge, and internalizing so much knowledge in a short time is usually an impossible task. Even if you cram the study into a very short period of time, even if you manage to pass the class, you will have problems internalizing the material, and you will need the class for further classes. This is why study should be all over the semester and not only at the last 2 or 3 weeks. So what I would like now to do is to show you some stages in learning, and how to do it effectively, and how to use the time that you have studying at home in order to better understand the material and be able to solve homework problems. So here are some steps. The first phase is understanding the concepts and the definitions that are being taught in the class. So first of all, make a list of the concepts and definition that were learned in the lecture and the recitation. And then in the second phase, check if you understand the definitions. For example, let's say that the lecturer showed you what a polynomial is. In the lecture provided a polynomial and showed one example of a linear function. That is a polynomial of rank 1. So as a student, you will need to check that this is indeed the case. If it doesn't work out, if you don't understand why a rank 1 polynomial is a linear function, then something is wrong. You need to understand why this is the case. So maybe you didn't understand the definition correctly, then you need to go back to the definition and make sure you understand it. After that, you need to memorize and recite the definitions, just to make sure that you really internalize them. And then you need to examine yourself. Write the definitions that you have memorized. So this is the first phase. We understand the concepts and the definitions. The second phase is understanding the proofs. So what do we need to do? First of all, and again, this is assuming that your course provides proofs. Not all mathematical courses have proofs, or at least not to an extensive rate. But if your course has proofs, then you need to understand them. Why? Because in many cases, the methodology or the way the proof is being constructed will be repeated itself in the homework problems or in the exam, in the final exam. So first of all, make a list of all the theorems and lemmas that were taught in the class. So first of all, what was learned. Then examine whether you understand the insight of the theorems and lemmas. I'll give you an example. Let's say that you have a theorem. This is a theorem that is taught in a calculus or pre-calculus class. If f is a one-to-one function and onto, then f has an inverse function. So we don't need here to understand what is a one-to-one function and what is an onto function and what is the definition of an inverse function, but we understand from what we heard that there is that in the definition there is a tool that that helps us to prove whether a function is an inverse, can be an inverse function. That is, in the problem that requires us to solve or to prove that a specific function has an inverse, it is sufficient to show that the function f has two properties, that is a, one-to-one, and two onto. So, so this is the insight of the theory. Then examine that you understand all the stages of the proof. That is, that you understand all the transitions that occurred during the proof. Again, the reason is because you may find these stages in either in homework problems or at the final exam. And then at the end, the last stage is examine yourself. Examine yourself, try to see that you can write the proof without using the course notes. Now you understand the material. This is the time that we need to start solving problems. So first of all, we start by solving problems for which we know the solution. And the first ones are the problems that presented during the recitation or during the class. Then once we know how to solve them, we try to link them to the material that learned in the lecture, to which subject each one of them relates, and then try to solve the questions without consulting your notes, and try to solve them and see whether you understand how to do that yourself. And once you know that, you're ready to do the homework and you are bound to succeed doing your homework. Now, it might be that you still cannot do solve the homework, cannot do the homework successfully. So check to see if you understand all. So in that case, we need to go backwards. We need to check whether we understand all the concepts mentioned in the problem. For example, for a problem that that we need to prove that a function f is a one-to-one function, do we know what is the definition of a function? Can we give an example of a function? Can we illustrate a relation that is not a function? Do we know that what is the definition of a one-to-one function? What is an onto function? Can we give an example that of a function that is not one-to-one? If we understand that, then it will help us to solve, to prove that a function is a one-to-one function. So we need to characterize what we don't understand in order to go back and follow the material. Once we understand the concept, then we need to look at for a similar problem that was solved either in the lecture or in the recitation, and we need to make sure that we can solve this exercise without consulting the note. If we didn't succeed, we need to go back and see why we didn't succeed and what didn't work, and then only then try to go back to the homework problem. Another thing, we need to, if we don't understand, if we're stuck, pair learning is a great tool to do that, as well as contacting the lecturer, contacting the person who recites, and getting help as much as we can. Studying tips. I will end by some studying tips. First of all, study in order to achieve the maximum score, not just to pass the course. There are two reasons for that. A, it's because if you study for a higher grade, there is a good chance that even if you didn't understand everything, you will end up collecting enough points in order to pass the exam. But really the other and the more important reason is because whatever you study in math, you will end up seeing in second, third, and fourth year of your school, and you will use it. So make sure that you have the necessary background knowledge. Another thing is you can prepare a notebook of terms and definitions with at least one example for each definition. And if you can indicate on which page the term of the definition appears in your notebook, or have a reference. You can do it also electronically. And that way you will have some kind of a summary of the material that it will help you to go back and forth whenever you need it back to the material. And the most important thing is that you need to know yourself. What is the best learning method for you? At which hours you are most prolific in your learning? What helps you more? Looking at videos, writing the material of the lecture. When you summarize, do you prefer, when you go to the lecture, do you prefer copying from the board, or maybe you can rely on your friends and use their, and you will listen to the lecturer, and you will use the notes of your friends. You need to understand what works well for you, and this is a matter of experimentation. And you despite of what I'm saying here, use what works best for you. Of course, I wish you good luck in your studies. If you have questions, I will be very happy to answer.
Thank you very much, Nissim. I think we will continue with Konstantinos Petridis, and then after his talk, I think we have time for questions. But in the meantime, if you want, you can use the chat, and here put there all your questions you have now, and then we can discuss later on, if it's okay for you.
I would like just to end with one more sentence, if I may.
Please.
It seems that what I presented here takes a lot of time. I understand that. The thing is that when someone doesn't succeed in doing homework, and the homework problems, they look at the homework problem, the homework problem looks at them back, and they look at the homework problem again, it takes also time. It takes a lot of time, and it's better and less frustrating to be ready to solve the homework problem beforehand, instead of just going and trying to solve the problem in advance. That's it.
Okay, thank you, Nissim.
So should I continue?
Kostas, you are ready to continue?
I'm ready, yes. Let me share my screen. Oh no, just a moment, because it needs this permission.
How you give me the permission?
No.
Maybe I can give you the permission back. We can see your screen now.
Okay, so good afternoon, good morning, I'm sorry. I was transferred myself to Uzbekistan, that is like later than 12 o'clock. Thank you very much, Nissim, for the nice presentation. What I'm going to do is like somehow I'm going to be complementary to what Nissim has mentioned. And I would like also to clarify that this project also was a shared thoughts between me and Nissim, and also Nissim is one of the initiators of this project. So probably, you know, my presentation will continue in the same manner. I will try to be focused more in the attitude that the students should have towards mathematics, and also towards any STEM course. As Nissim has mentioned, I was one of the kids that I was afraid of mathematics very much. I was forced to learn mathematics. I was performing in mathematics, but I don't know how. Probably it was my fear that pushed me in order to perform. But since yesterday that I followed Ronnie's talk, I think that I was a very low performer. Based on the questions, I was hardly be able to answer any questions in an instant way. So whatever I'm going to say to you is within the framework of a pre-calculus course that I'm running, testing item procedures and principles in my university with say, two colleagues of mine, Dr. Kokinos and Dr. Zakinthinaki. So it is a test. So this test has been also a part of the fundamentals of a pre-calculus course, like how to learn about equations, how to learn about functions, integrals, and differentiation and geometry. I thought that probably it's a nice way to introduce to the students how to learn mathematics from my perspective. Of course, my perspective and also perspective of the bibliography. So let me, I will share some videos with you. I don't have the time to run all of them, but I will keep, the message and I will go on at the end.
Kostas?
Yes?
Please, you have the second screen here with us. You have to change it.
All right, so.
Yeah.
So now?
Yes, now it's good, yeah.
Okay, very good. So let me play the video then. I don't know if the voice works.
%26%. On the nation's report card, that's the percentage of US 12th graders who are proficient in math.
So this is in the
In
States.
America, we pride ourselves as being an exceptional country, but does 26% sound exceptional to you? Raise your hand if you think as a country, we need to do way better than this. I'm with you.
So I will leave you to see the video later on because of the restriction of the time. I will share my presentation with you as the rest of the presentations. I would like to mention that the problem here is that this guy, he's a high school teacher in California. He has identified that the main problem is like how do we teach mathematics, but also how do we teach the students, our students, to perceive mathematics. It's not only the material, it's also the attitude that our students, we should teach our students to have. So let's move on. So I would like to say to you, like based on my mistakes as a student, many years now, even near to the Second World War, probably, because I'm quite old, there are some myths that we should knocking down about mathematics. Mathematics, this is what I try to say to my students, is a language, it's a human language. I mean, probably I wrote an article, I read an article that in ancient Greece, the people, they used to communicate using mathematics. So it's like a language, it's a language that we communicate. It's the same like, I mean, if we know how to speak mathematics, we can communicate. Even I don't speak Hebrew, or if I don't speak the language in Kosovo or the language in Uzbekistan, using mathematics, we can communicate. So there is also a specific mindset that we should have towards mathematics. We should not be afraid of the mathematics that you will see. We should not think that mathematics is only for these talented people. We can grow up and we can be improved by working hard and be exposed and doing mistakes. Doing mistakes is something very important in order to learn mathematics and anything else. And also linking mathematics with real life. This is the most important thing. Like to be able, I don't know if you have seen the movie A Beautiful Mind. I don't say that all of us, we should be like the beautiful mind, but also we should see around us, and you can see the symmetry, you can see mathematics everywhere. I will feel very happy when I will realize this moment. So, I mean, this is another video how people, they react if they listen the word mathematics. So
a lot of people, as you may know, have a bad relationship with math. Often they don't like it or they don't do well in it. This is partly because of things they don't know about math that we will show you in this course.
We went to San Francisco and asked people what they thought about math. How do you feel about math?
Look at his face.
How do I feel about math? Let's see, I use it at work. It's a tool. I'm not sure I guess in some ways you feel it if you can relate it to nature, but I don't know. I feel math in a sense. Not when I study just math, no.
Why?
Because I can't understand it unless it relates to something physical.
This is one
math?
of the...
You're joking.
How do you feel about math? How can you have a feeling about math?
So
I love math.
I will leave you
And
as
I
well
think it's,
to see this video later on by yourself, but look their reactions. You know, the people, you know, they have a bad perception about what is maths. Maths, you know, for any scientist, for any profession, starting from philosophy all the way to the STEM, is a very important language. It's the language in order to understand your discipline. All right, this is very clear that we should say to our students, and we should, yesterday we had a lot of tips how to make the teaching of mathematics not just dry and monotonous. So the myths about the mathematics that I would like to address you is like a lot of us, I mean, included me, I don't want to include you, but, you know, including my students, they think that, you know, you should be a talent in order to learn maths and how to use maths. Maths, they are not linked with real life applications. What it be, and we can see this. In the university that we teach, maths are different courses than the specialization courses. I'm teaching electronics, all right? So I'm pretty confident right now that I can teach maths through my electronics course. Why these two courses, they should be independent? This is the biggest mistake that we are doing. We are treating maths like, you know, something that comes from, let's say, from Mars. All right, inside our university. So this makes people do not make, you know, this link between their discipline and math. And this makes, you know, maths boring because, you know, maths, they are linked with real life problems, and you know, it's something that makes them interested, because the students, they should know from the very beginning why do they learn about maths. So I will skip this. All right, now I'm not going to skip it. I will show it to you, and I will show you what is maths. For me, the next athlete, you know, math is like to go to the gym, all right? So if you're exercising, what is happening? Look, Arnold Schwarzenegger, he was the champion in on the bodybuilding, and why? Because he was exercising all the time, he was going to the gym, he was elevating the difficulty of the game, you know, not, you know, the most athletic, but, you know, a champion in bodybuilding. So, I mean, for me, what is math is like exercising and getting gains. I will come on what Nissim has mentioned about working together and stuff like this, but everything is exercising, all right? So everything is exercising, applications, do not afraid to do mistakes, as you will see. Doing mistakes is very important for this network here. I mean, you are making your mistake. When you realize a mistake is the moment that you are learning, you know, what are you involved in. So, I mean, as a teachers, we should not criticize mistakes, but we should encourage mistakes so that people do not afraid to do this and make the synapses in order to realize things. So there are different mindsets. It's like the fixed mindset, and also it's like the growth mindset. I will say that our students, we should learn them, or us as a students, because we are students, no? We are academics and scholars. We should learn and study every day. We are learning new things every day. So we are students, you know, even though that we consider ourselves, you know, like scholars. So I will say that, you know, the right attitude that the students and us, we should have is like when we say, I cannot do this, I can do this yet, I cannot do this yet. I'm not good at this, I can become better at this. When we say, what grade did I get? What can I do to get improved? All right, this should be the attitude towards anything, and also towards mathematics. So two mindsets according to the bibliography, like growth mindset and fixed mindset. I mean, if we follow all of us, the fixed mindset is like we welcome this kind of myths about mathematics, that mathematics is something difficult, mathematics is something that only Kasparov, you know, the Soviet, you know, or the Russian champion in chess can learn. No, this is not true. I mean, if you work, and if you work hard, and if you don't afraid to do mistakes, you will become a very good student or a user of mathematics. And this is important in order to communicate within your discipline, in order to understand better your discipline, in order to be creative. So this is something that we should do. Go from a fixed mindset to the growth mindset. So it is very important, and this is the first step that, you know, the students, they should do. They should accept, and they should say, I will work hard, and I can get improved in learning mathematics. So you should try harder and longer. you should see the failures as an opportunity. I know that, the ego comes between us and, the reality, but, doing mistakes, as I told you, is the first stage of learning. I mean, if you're afraid to do mistakes, you will never do. We used to say that the person who is this one that is not doing mistake is this one that is doing nothing. So learning, the first thing that you should do is like do a mistake, but of course learn from the mistake. Because if you are doing mistakes and you are not learning, this does not help you the knowledge pathway. So you should be persist and you should look ahead. All right. So be aware of the fixed mindset. Don't employ. This is a myth. Mathematics is something that anyone can learn. Anyone can excel. So I'm moving this. This is something that I said that, this is like based on the neuroscience, that they used to say that we are learning if we encourage the synapses, and the synapses will be permanent. This electrical, signal, and this electrical connection will be permanent if we learn from our mistakes. And not only this, we are going to sustain this like Schwarzenegger. I mean, we would like to go and test ourselves in elevated challenges. I can see here, my colleague George Fuskitakis, who is like now a professional, like cyclist, and he started with his mountain bike to come to the office, and then he was elevating, to a very long distance ridings, and this is what is exactly in everything. You elevate the problem in order to get improved. So engage, work hard, do mistakes, learn from your mistakes, and then elevate. Life is the same. We used to say in physics is everywhere. I can say that maths is everywhere because I know as a physicist that maths is the key course to learn. Look, Thomas Edison. Look, some examples from very big innovative persons. Like, Edison was asked, how do you feel after 1,000 times of failing? And he said, I was not failing, but I was taking steps ahead. This is like how we should perceive mistakes. Genius or, innovation is 1% inspiration and 99% of sweating. Look, Michael Jordan, he was not afraid to do mistakes. He was a leader. He was leader of his knowledge and the way that he was learning. And he lost 9,000 shots before, and he has lost almost 300 games before he win. So another myth about mathematics is like you should be like F1. F1 is like, of course, a very scientific and a very high science product, but it does not mean that someone that reacts very fast to and gives very fast an answer in mathematics that he's the talent one or the special one. I will say that, the person that he's good in maths is this one that compiles things. It's like a maestro in an orchestra. It's like someone that he has worked hard, he has done mistakes, but he has learned from the mistakes. He has a feeling. This is very important in all sciences, like especially, for the students, have the feeling of what is happening. And then you can compile things. You can use different perceptions in real life problems. And this is like what Ronnie has mentioned yesterday in order to be innovative. In order to be innovative, it's just like memorizing. It's just, in order to be innovative, it's like to learn how to combine things. How you can see through the electronics, the maths, you can see through the physics, the maths, and then use the maths in electronics and physics in order to reply to real life problems. So another thing is flexibility. I mean, after you have realized your stuff and after you are confident about maths, I mean, you are going to learn the first step that, the correct solution it does not contain only one path. I mean, there are different pathways that you can solve a problem. So when your professors will solve a problem, think of an alternative in order to reach the same result. All right. So flexibility is something that will help you with numbers, will help you for you to learn better, mathematics. There is not only one way to solve a problem. So this is something that, I just said. So I'm moving on. This is an example. Like look this product, 18 times 5. How are you going to do it? Different ways to do it. Yesterday, I was looking this transparency and I was asking my wife because, I could not understand some of the solutions. But you can see, you can learn and you can visualize, this product in 4 different ways. And I'm pretty sure there are more. This means, flexibility, innovation, and this is linked with what Ronnie has mentioned. So try to reach the correct answer because the correct answer is only one. But, to reach this correct answer, there are different pathways. what Nissim has mentioned before is like speak with the others, learn by the peers. So this is very important because we are going to discuss. And when you discuss, you should back up your results. You should back up your position. And the best way is using maths. People, they love numbers, all right? And if you can back up your results, independent if you are a physicist or you are an engineer, you should back up, the things using numbers. Numbers convince people. And, the methodology to reach this number, convince them even more. So learn with your colleagues, learn between you, talk about maths. This will make you familiar with the terminology, the combination, the creation, and this will help you a lot in order to familiarize with maths. And reasoning is something that I say to you, reasoning means, to connect ideas and this convincing people. And then a part of the flexibility with the numbers and reasoning is like mathematical connection. Like, from an event that you observe in the laboratory. I'm doing laser physics. So I'm observing all the time, in the laboratory, some phenomena. So the first thing that I try to do, not successfully until now, I have to say, is like to link and find, a mathematical function that, will allow me to predict, the design of my laser system or the phenomenon that I would like to say. And think about this. Think about functions. Functions are described using 4 different things: the formula, the measurements, and the visualization, the graph. Okay. So that's it, what I would like to say to you. I think that I was on time. So the thing that I would like to tell to the students and to all of us is like, first, go down, lift any myths about mathematics. Mathematics is something that we can do. The only thing that you need is like work. It's like, first of all, engagement. Lift the fear. Second, learn from your mistakes. Do not afraid to do mistakes. Mistakes is very important. Look what Edison has mentioned. Like, you are learning from the mistakes. It's like a route. In order to acquire the knowledge, it's not an easy way, but it's not a hard way. It's like you should be committed in what are you doing. You are doing mistakes and you are learning by mistakes. And the feeling that you have or you will get when you realize things is like the best gift that you can give to yourself. You are feeling very happy when you realize things. And then, as Nissim has mentioned, we can learn from each other, we can communicate, we can speak this language. That's a human language. Mathematics is a human language. It's something that people, they like. If you have a statement, the people, they would like this statement if you use, the numbers and you can back up your statement. So these are some tips to the students and to myself included, because I'm considering myself as a student. So thank you very much. I don't have anything else to say.
Thank you very much, Costa. This was a very nice presentation, and thank you, Nissim, as well. Are there any questions right now to this topic? I think there's nothing. So what I can summarize is to work hard and to find different ways to learn. And Nissim, what I would like to ask to you is, I think this concept of peer learning is very helpful, but what I can see is it's hard that the students will really do it. Do you have any ideas, or how can teachers support to motivate the students to go this way for peer learning?
I think that the way teachers can help is by demonstrating in class that peer learning actually works. And that means that we need to do it, to stop either in the lecture or the recitation, and make sure that student work, divide the class into pairs, and make sure that student work in pair, and then first of all, in some ways you create these pairs of learning because they already have learned like that during class, and also you demonstrate how this works. The challenge that we have is that with the COVID-19 pandemic and the fact that learning is done from a distance, it's very difficult to do that technically, because technically students cannot share their ideas unless they have some way, some easy way to share either a screen or some kind of a shared medium. The problem with that is that unless they have a tablet with a pen, they cannot write easily formulas, and that way it just doesn't work. My experience is that I mean, I try to do that, and very few students participated. But when I did that in a face-to-face class, it was very easy and very effective. So I don't have a way to overcome this challenge. Just get vaccinated and we'll get over it.
Yeah,
So.
I think Israel, you are
Can I add
in a
something
good
to
way.
this? Can I add something on this?
Yes,
I mean,
please go.
based on what Nissim has mentioned, we tried here, of course, in electromagnetism, we have tried this, and it works very nice. Even during this COVID-19 and during this isolation, we tried the Scrum method. So students, beyond, following the lectures, the online, and then, every day they are meeting, of course, using virtual rooms. But after, let's say, some sprints that we used to say, they make presentations, and it seems that it works very nice. I mean, I was very much impressed by the presentations that the students they are doing by working together, engaged, of course, virtually, but meeting every day in order to achieve, the small sprints that we have set to them. So even though that I totally believe that, COVID-19 and this face-to-face interaction is very important, I will say that, there are, some kind of, let's say, pedagogist attitudes that can be applied even these days. Like the Scrum in education is something that it seems that it works very nice for us.
The thing is, I think that it depends on the subject. For example, I'm teaching both computer science and mathematics. When I teach computer science, I can divide the class into pairs, and it works well because they share a screen and they together write a code. It works excellent. But when I try to do that in math classes, they just technically, they don't have a way to write the formulas well. And because we don't have a good way. I mean, they're not proficient in writing math in using Word or using LaTeX, and unless they have a tablet, it just doesn't work. So I think this is the main challenge that I see.
Yeah, probably.
Okay. Yeah, thank you. Are there any questions? I think some students are here with us. Do you have experience with peer learning? Can you tell us something, or can you
Excuse me. Can I have some comments?
Yes, please.
First of all, hello to everyone. It's a pleasure to attend this course, seminar today and yesterday. The presentation of Professor Nissim and Petridis were very nice for students, also for us like a teacher of maths. I want to say something. The students think because the math is very difficult, and they have a fear from math because the math is like a chain. If the student doesn't know the unit, any unit, the chain breaks. So here is the problem, because they cannot solve the problem, or some like example, the Nissim said for the inverse function. They cannot prove the theorem because they don't know what is one-to-one function of that. So if they don't know what is one-to-one function, they cannot prove the theorem for inverse function. This is the matrix is like a chain. that if the student doesn't know something, any unit, the chain breaks, and this makes the math hard. It's only comment to the.
This is very true, I will say.
Thank you.
Very true. And what we are trying to do in HMU is like through the item, of course, project, because item project was a great chance for us, is like to introduce this pre-calculus course, like to try to link the university mathematics with the knowledge that the students they should have, and at the same time to try to encourage them to have a correct attitude towards mathematics. Do not afraid the mathematics. Until now, I mean, we have managed to introduce the course, but we need more work to do in order to shape the correct attitude. But yes, I mean, as in any specialization, I would say, even more in mathematics, that you should have all the parts of the chain, as Ser has mentioned.
I think that one way, sorry. I think that one way to help students with the challenge is to provide some kind of what we call an aquarium, which means that there is a space where they can ask any questions and they can get an instructor, maybe the instructor that is there for maybe 2-3 hours and answer questions on that relates to prior knowledge or any other question that helps them. Usually the problem is not that students don't understand anything. It's just that they are missing this part or that part. And if they have some kind of help that can help them overcome this hurdle, then they realize that they actually understand the material. The thing is that also demonstrating to students that they can succeed once they have the prior knowledge helps them do it themselves at later stages in their studies.
Another issue that we have seen and we try to overcome this is like when the people, they don't know this part and this part, because they feeling that they should have this knowledge, they are shy to ask, especially within audience. So what we are trying to do with one of my PhD students, we develop like a software that they can be applied on the mobile phone, and when someone is teaching, an anonymous question which will be appeared on the screen of the professor or on the projector. So it will be anonymous, and the rest of the students, they will support this question if more of them they have it, like by placing like. It's something that we would like to try, in the next semester, in order to overcome this. Like it's a combination of fear and shyness, I will say. But as you mentioned, it's never late. Engage, cover the missing parts, and you are going to excel, because mathematics is something. It's something like it's a language of science, I would say.
Thank you very much for this. It's a good idea, Kostas. I hope it will work well, and I think it will help students to overcome this fear. I think that's what you said, and listen, what you also do with your aquarium. I think that's very important. Yeah, that they try to not to stop thinking, and that they encourage to go further. So, okay, thank you. Now we will, Eva, you are with us. I can see you. Yes, you're here. Oh, nice to see you.
Yes.
So, okay, now we will start with our next session from Dr. Eva Tiantifiu from Aalborg University in Denmark, and she will present us something about problem-based learning in mathematics. And in this session, we will try to make a short breakout room. So I say we will try it. So we are a large group, and the group is always changing. Sometimes we are 100 and then we are 80. So if you will start with the breakout room, we will see how it works, and then yes, we will see. Please, Eva, now
Yes, thank
we
you.
are
Thank
happy
you.
you are here.
Yes, thank you, Renata. Thank you very much. And thank you, everyone. Thank you, Costas, and all the item partners for the invitation. I will share my screen first, and then, I mean, we will try, if not, if we're not going to be able to use the, just give me a second, to use the breakout rooms, it's also okay. It doesn't matter. We can also do it. Yeah, like in the plenary room. So I hope now you can all see my screen, and you should also be able now to see my screen. Still just one slide. Yes. So I was invited today to talk about problem-based learning for students, and problem-based learning is a pedagogical approach that my university, Aalborg University in Denmark, applies for many years now. And I know that like it's impossible to make students work on problem-based learning, especially because I know that most of you study in other universities, and not if not all of you. So I tried for today to think what I can discuss today that maybe you can take with you. So today I will try to speak about, of course, what is problem-based learning, very briefly. And then also because problem-based learning is based on real-life problems, I will try to show you with breakout rooms, fingers crossed, how to work and learn using and investigating and trying to solve real life problems. And then for finishing this lecture, I thought about discussing some problem-based project skills that we teach our students. And I would like at least to discuss with you today that you can hopefully use, in your professional work, even in your private life, I would say. So it's about project management, it's about time management, it's about collaboration, it's about how we listen to the others, how we are good team players, something that is very valued also in the professional life, etc. So a very brief introduction to the university. So Aalborg University, the main campus is obviously located in a city called Aalborg, which is here in the north part of Jutland, the continental part of Denmark. But Aalborg University has also two other campuses, one in Copenhagen and one in Esbjerg. And I'm located here in Copenhagen, which is the second largest campus of the university. Also, the university covers almost all disciplines, so from social sciences to humanities to engineering to medical studies to IT and design. Of course, not in all three campuses, but at least in, there is a good coverage if we combine all three campuses. We do have also some international students because we have master in English, master programs in English. And as I said before, the university, since its establishment in 1974, applies a pedagogical approach into learning called problem and project-based learning. The idea is that our students, every semester, apart from the courses they have to follow, they are asked to work in a project, a group project, so they're working together with others. And in these projects, they have to find a problem from real life and then try to find a smaller problem within this domain, this context, that they can solve with the knowledge of the specific semester or the theme, because every semester has a theme. For this project work, they have a teacher, a supervisor who guides them in the process. So every group gets an individual supervisor. And at the end of the semester, this project is evaluated with an examination. As all the other subjects, the examination is oral, but all the group participates, and people get individual grades for this evaluation. So they are evaluated on their individual contribution and knowledge on the project, and not only the project itself. Now, I'm going to discuss a bit the problem-based learning approach on how to, work with a problem, just that you get an idea of what it entails. So first of all, the students in almost all semesters, apart from the first semester where they are new, in all other semesters, the students form groups themselves. Of course, there is a coordinator, present when they do that, but the teachers and the coordinator do not interfere in group forming. What is important is that everybody joins a group at the end of this process. This is a good regulation strategy for our students, because students in some cases choose to work with different persons every semester. Some students stick on the same groups, and also some students who at the beginning fail to contribute enough face the consequences, because later on other students do not want them in the group. So this is, as I said, a regulatory process also and a reflective process for the students. What can I do better so people would like to work with me? Then the students should formulate a problem within a context, within a topic for the semester. They have to decide what tasks they have to do for solving the problem, gather data on the problem, as we will see, as we will try to simulate today. So they have to go and look, okay, is this really a problem? Are there solutions to this problem already? What can we do to improve maybe existing solutions? Are there maybe, are there some solutions that they are missing, and we can work on that, etc. And then not only that, but also what are the target groups for this problem, what is the context, and of course, make choices. And then after doing that, as we say, they analyze a problem, they come with a final problem statement. So this is actually a specific and very, a problem that they can solve within the next 2-3 months. We call this process of analyzing the problem analysis, as we call it, is very important, because they follow a scientific method on analyzing. So they try to find literature, scientific literature, and they learn the academic way of, citing, reading, judging the source of information, and all that. And and that's why the problem they get in the beginning, we call it an ill-defined problem. So it's in purpose, it's a very vague problem. So the students, they have to dig a bit and find a very concrete problem to solve. And this is a learning process, although it can be frustrating in some cases. After they do that, they design a solution, implement the solution, and evaluate the solution with, really contacting the target group. That's why it's important to know what is my target group. So they try to contact the target group and discuss, on the solution. Through the whole process is documented with a report. So just to show you the semester, as I said, it contains 3 courses that are supposed to actually support the project work. So they are all related to the semester theme. And that's why they are given in the beginning of the semester, and then the project work spans the whole semester. Now, for just trying to see, to experience how it could be to work, on a problem-based approach, I would like to work in breakout rooms. I have asked Renate, who was very kind to help me with that, to arrange, people in 6 to 7 people per room. And then for a few minutes, because the time is limited, let's say around 8 minutes, I want you to brainstorm with the other people in the room and try to define a problem related to COVID-19. The buzzword these days, the pandemic, that can be solved within the discipline you are studying or you are teaching, if you are a teacher, and by employing mathematics. So try to think about a problem that you can solve by applying your discipline and mathematics, but you have to take into consideration, or at least you have to discuss within your group, is this really a problem? How can we find out? Yes, so I may have an idea, I think I can solve I don't know, something with mathematics. First of all, how can we know that what I think is a problem is really a problem? And then you can also think maybe existing solutions to the problem. Is there any unrealized potential there? So of course, most probably solutions will exist even in problems that you will think, but try to think if you can add extend or improve existing solutions. And then if you have the time, try also to think on a target group. So which is our target group, which is the persons or the sector we want to support with solving this problem, and also think about the context. So I don't know if there are any questions on this, but Renate, shall we give it a try? Maybe I can stop sharing my screen.
Okay, wait a little.
Yes.
I think so. How we can try to create now the breakout rooms? I built different rooms with country names, and you have to choose which room is good for you. I think we have 9 from Kosovo, and please. Only 6. I think you would give 6 persons per room. Okay.
Okay.
And now we are here in a mathematics lesson, and I think it will be possible to count from 1 to 6. So we will see. And after 10 minutes, we can go back, or you can give me a signal and I can give it back.
Yes, someone asks for an example, and you can think first of all on the different domains of if we talk about COVID-19, there is, for instance, a domain which is the economy, so the impact on the economy that COVID-19 has. It could be the impact on travel. It could be vaccination and distribution of vaccines. It could be, it depends on your discipline again. It could be on, I don't know, on treatments and vaccines if you are a bit on the medical, or if you are nowadays also for finding actually medicines. Many people use computer science, they use machine learning, etc. So I don't know, it depends on your field of study. It could be, I don't know, it could be education, online education, because COVID-19 has a great impact also on online education and digital education. It could be, I don't know, I just gave, and this is part of the brainstorming. So now I did a bit of a brainstorming for you. Yes. So this is the main thing I want you to do in the breakout rooms. So I don't want to steal more of your time. It would be nice when you're back, if some of the groups want to just post, ascendance of the problem. How can we use mathematics and whatever else maybe to solve this or to improve that, or it would be nice. Yes, let us try to do that.
Let's
Yes.
try again. Oh, wow. So how can you see now? Not the rooms, or can you choose?
Yes. If you click on the breakout rooms button, it should be next on your menu.
Yes,
on the menu you have below, there are different breakout rooms based on the country. So you can join any breakout room. I mean, there's one from Greece, several from Kosovo, because there are many people from Kosovo, I guess.
I didn't have this view, but Evangelia, you think it works? Okay.
I can access if I press.
Πετρίδη, μόνο εμείς οι δύο είμαστε Έλληνες. Θα φωνάξω και τον Μεγιστάνα από εκεί πέρα. Δεν σ' ακούω.
Πού είναι ο Μεγιστάνας?
Ο Μεγιστάνας έχει meeting. Από meeting τι να σου πω, άλλο τίποτα. Εσύ τι κάνεις?
Κι εγώ από meeting σε meeting πάω.
Κάτσε, ακούμε μουσική από μένα ή από σένα?
Εγώ δεν ακούω καμιά μουσική. Μήπως κάνουν τα παιδιά σου μουσική?
Όχι, εγώ έχω μουσική. Τίποτα έψαχνα κάτι πριν γι' αυτό. Τι κάνεις, είσαι καλά καταρχήν?
Καλά είμαι, μωρέ, έχω κάνει πολλές στο κεφάλι μου και δεν κοιμάμαι.
Γιατί ρε δεν κοιμάσαι?
Αφού έχω πάρα κάθε μέρα έχω κάτι. Επομένως, ξέρεις, και αν το οργανώνεις είναι πιο δύσκολο.
Η οργάνωση είναι πάρα πολύ δύσκολη, σε καταλαβαίνω πάρα πολύ. Τι να πεις, τέλος πάντων. Ελπίζω να περνάς, να έχεις κάποιες όμορφες στιγμές, γιατί τα χρόνια περνάνε.
Το ξέρω μόνο, το ξέρω, το συζήταμε και με την γυναίκα μου. Δεν έχω καθόλου χρόνο.
Η Μαρία είναι καλά?
Μια χαρά.
Μετρίδης είναι?
Έλα Μωριάνο!
Τρελιάρι! Κάτσε, choose video part.
Τι κάνεις, παλικάρι μου?
Κάτσε, μην πει κανένας άλλος. Καλά, εσύ?
Πώς πάει?
Άμα μπήκε.
Καλά, εσύ? Βλέπω το μεγάλο παιδιό έχει εξελιχθεί σε άντρας, έχει γίνει πλέον, έτσι.
Ποιος, και οι δύο.
Εννοείται.
Και οι δύο μεγάλοι.
Με το μεσαίο δεν τον βλέπω, αλλά ο μεγάλος κάνει στο Facebook, βάζει φωτογραφίες.
Όχι, ο Μιχάλης άλλαξε, ρε.
Ναι, είναι άντρας.
Ναι, άντρεψε.
Έλα, έχει και μουστάκι και μουσι.
Με τις σπουδές του τι κάνει, τελειώνει φέτος ή του χρόνου?
Φέτος τελειώνει.
Τελειώνει σε ένα μήνα. Μα βασικά σε 10 μέρες.
Σε 10 μέρες τελειώνει
το σχολείο.
Έλα να σου πω, και τι θα κάνει τελικά?
Κοίτα, καταθέσαμε στο Τσάρλς.
Ναι, καλό πανεπιστήμιο.
Καταθέσαμε στη Βιέννη και θα δώσει και στην Ελλάδα.
Εντάξει, ωραία.
Οικονομικά και αρχιτεκτονική. Οικονομικά, business, politics, τέτοια και αρχιτεκτονική που του άρεσε.
Μαλάκα, σας στείλαμε και τα Patriot κάτω εκεί να σας προστατεύουν.
Αγόρι μου!
Η Εμένη θα σας έρθει από κάτω τα ξυπόλοιπα.
Άσε, οι βόμβες έρχονται.
Κοίτα, όπως είδες.
Μου τα λέει και ο Ανθόπουλος. Στο κάος συνέχεια έχει συναγερμό άμα...
Έχουν αντιπυραυλική, όλα ρε.
Απέναντί μας έσκασε.
Σκέψου ότι η Αράμκο έχει κοινό τοίχο με το πανεπιστήμιο.
Ναι.
Δηλαδή τώρα το μεσημέρι θα πάμε στην Αράμκο, θέλουμε 10 λεπτά. Απλά αργούμε γιατί περνάμε ένα security control.
Ναι.
Όλοι οι πύραυλοι που έρχονται, τα drone έτσι τα χαμηλά, έρχονται για την Aramco. Έτσι προφανώς. Λοιπόν, και σε κάποια στιγμή εγώ δούλευα, ήταν 9 ώρα το βράδυ και κάνει μαλάκα μία έκρηξη από τα αντιπυραυλικά, έτσι, στον αέρα το κόψανε.
Ναι.
Μαλάκα, λες και γινόταν σεισμός 15 ρίχτερ. Η Δέσποινα έκανε κολυμβητήριο, οπότε δεν κατάλαβε τίποτα. Αλλά τα παιδιά κατέβηκαν κάτω χλωμά. Μου λένε, μπαμπά, τι έγινε. Λέω, χαλαρά, παιδιά, χαλαρά.
Λοιπόν, αν δεν κάνουμε το break στο μου, φύγε. Έχω ούτε 4 λεπτά δεν έχουμε. Τι θα κάνουμε.
Αφού εγώ είμαι το αφεντικό, τι σε νοιάζει.
Έλα, τι θα πεις, εσύ θα τα...
Εγώ ξέρω τι θα πω. Κοίταξε, θα πάμε με το vaccination. Έτσι, τι rate γίνεται στην Ελλάδα καθημερινώς, πώς αλλάζει αυτό το rate καθημερινώς, μέχρι να φτάσουμε μία ανοσία σε κάθε ηλικιακή, πώς να το πω, ηλικιακή ομάδα πάνω από 70%.
Ο Μιχάλης εμβολιάστηκε.
Ναι, κάτω στις εμβολιά. Εγώ είμαι τώρα αυτή τη βδομάδα.
Ο Μιχάλης εμβολιάστηκε και πήγα σήμερα να εμβολιάσω και τον Γιώργο, αλλά μου είπαν ότι επειδή είναι από 16 έως 18, σε εμάς η οδηγία λέει πάνω από 16.
Ποιο εμβόλιο κάνετε?
Pfizer, τα παιδιά από Pfizer. Εμείς κάναμε AstraZeneca.
Επομένως, κάτσε από τη Δέσποινα, γιατί θα μιλήσει η Δέσποινα. Δέσποινα, έχουμε... Εγώ θα μιλήσω. Εγώ δεν πρέπει να μιλάω. Έτσι.
Γιατί εσύ τώρα...
10 εκατομμύρια ανθρώπους. Έτσι, άρα θέλουμε να κάνουμε βαξινέο το 7 εκατομμύρια. Γεια σου Παντέλο, Σαουδάραβα πρίγκιπα. Λοιπόν, άρα θέλουμε 7 εκατομμύρια. Θα θεωρήσουμε ότι στα 7 εκατομμύρια θα βάλεις ότι στην Ελλάδα το 40% είναι στην ηλικία πάνω από 50, γιατί αυτό είναι, και κάτω από 50 η υπόλοιπη ηλικιακή πώς θα το πω, ομάδα. Αρχικά, επειδή ξεκινήσαμε με το μεγάλο ηλικιακό group, έτσι, είχαμε ένα rate, πόσο ήτανε το vaccination, ήταν γύρω στις 100.000 την ημέρα. Εντάξει, επομένως...
Αλλά λεπτομέρειες πρέπει να πούμε. Τόσες λεπτομέρειες πρέπει να πούμε.
Γράφε εκεί πέρα. 100.000 rate η πρώτη ηλικιακή μερίδα. Δες πόσο πληθυσμό είναι στο 40% του 7 εκατομμύρια. Έτσι. Και μετά πάμε και στην υπόλοιπη που έχει ανέβει το vaccination τώρα στο γύρω στις 150.000, στο 120.000 την ημέρα. Για να δεις πόσο καιρό χρειάζεται να φτιάξουμε την ανοσία της αγέλης, που είναι γύρω στο 70%.
Πόσο καιρό χρειάζεται δηλαδή?
Εσύ αν έχεις 6-7 εκατομμύρια. 6-7 εκατομμύρια. Το 40% του 7 εκατομμύρια είναι το αρχικό rate που σου είπα. 100.000 εμβόλια την ημέρα.
Ωραία. Το 40%.
Μπράβο. Και επίσης, άμα θες να το κάνεις, Δέσποινα, αν θες να το κάνεις και λίγο με μεγαλύτερη λεπτομέρεια, από το 40% του 7 εκατομμύρια δεν δεχόντουσαν όλοι να δεν κάνουν το βαξίν, γύρω στο 60%. Άρα το 40% του 7 εκατομμύρια, το 0,6 αυτού έκανε το βαξίν.
Συγγνώμη, πρέπει να γράψω μαθηματική σχέση?
Όχι, αλλά έτσι αναλύεις. Πώς χρησιμοποιείς μαθηματικά και ένα real life problem. Άμα θες τα λέω κι εγώ, αλλά καλύτερα να τα πεις εσύ, μην τα λέω. Άμα κολλήσεις κάπου, τάκ.
Θα πεταχτείς, εσύ ξέρεις τώρα πώς πετυχαίνεις.
Θα σηκωθεί το F16, τάκ. Κατά τα άλλα καλά περνάτε?
Κατά τα άλλα καλά περνά. Κοίταξε, καλά περνάμε, δεν το συζητώ. Καμία σχέση με την Ελλάδα, δεν θέλω να γυρίσω ούτε εγώ. Μόνο ο Μιχάλης θέλει να γυρίσει, οι άλλοι δύο έχουν βολευτεί.
Ο μπασκετμπολίστας παίζει μπάσκετ?
Ο μπασκετμπολίστας δυστυχώς 1,5 χρόνο έχουν κλείσει τα πάντα, δεν έχουν ανοίξει. Εδώ πέρα είναι εδώ είμαστε, προσκυνάμε. Ό,τι μας λένε κάνουμε, δεν υπάρχει λόγος ούτε αντίλογος, υπάρχει μόνο λόγος του βασιλιά, ο οποίος όμως μας προσέχει. Δηλαδή δεν το βλέπουν οι άνθρωποι εδώ πέρα ότι...
Σαν τύραννο.
Είναι γκεστάπο, τελείωσε αυτό είναι. Η δικιά μας προστασία και ευγνωμονούμε και ευχαριστούμε. Τι να σου πω τώρα, εγώ θα έρθω τώρα στην Ελλάδα να τακτοποιήσω το παιδί.
Πάντως από άποψη οικογενειακής, έτσι, ευμάρειας και τα λοιπά, καμία σχέση με την Ελλάδα.
Καμία σχέση. Καταρχήν έχουμε μεγάλο σπίτι, ο καθένας έχει το δικό του δωμάτιο που το ήθελα εγώ. Στα Χανιά ζοριζόμουν πια. Πάμε online, όλα γίνονται διαδικτυακά, τα παιδιά έχουν γίνει expert σε αυτό και τους λέω συνεχίστε στο εξωτερικό, μάλιασε η γλώσσα μου, Μιχάλης λίγο τσινάει. Τον βομβαρδίζω όλη την ώρα να φύγει.
Okay, so the breakout room session has finished. I know that probably it was shorter than you would like to, let me return to the presentation. But it would be nice actually before doing that if you would like to type just some keywords or whatever, if you like, that the discussions you had in your group. And maybe
can we speak orally instead of typing?
Yes, we can also do that because I think there were a few groups, so we can definitely take all the groups. If they want. I don't want to press people, to to talk in the plenary. But yeah, Kostas, would you like to go first?
No, I will give the floor to the lady of my group because we are two people.
Of course.
One of them it was a lady, so I will give the floor to Despina Rusu.
Despina, yes.
I will compliment.
Thank you so much. You are a gentleman, actually, Petridis, because you gave the word. But anyway, hello to everybody. Okay, we have a brainstorming, as you said before, in all topics, in every aspect of real life. But we choose the vaccination, the medicine part, because it's a goal for every country, I think. So what we have now in Greece, almost we are 7 million the popularity. So we try now
Despina, we are 10 million, but we would like to reach, the threshold of 70% of vaccination. This makes 7 million.
Yes, I'm sorry. Yes, we are 10 million, but we want at least to have 7 million popularity of vaccine, and we believe that almost 40% is above 15 years old, and so the rest are down. So we start the vaccination with the very old people, but from this group we have a less number of vaccines for many reasons. Anyway, we start with a race, probably 100,000 of people per day. Right now, it's higher, and every day and every week or every month, we have a higher goal for more people to vaccine. So from this 40% from under 50 years old population, as I told before, they are not coming, all of them, for any reason. So we think that probably we have 6% less from this group. So as we can see, the mathematics got involved a lot in the whole thought, the way of thinking. What else, Petridis, now?
So, like to summarize, like we have, we consider, like, we took as a case study the vaccination rate in Greece. So we are making some rough estimation that we would like to reach, this safety level of 70% of our population to have been vaccinated. So this makes 7 million. So from these 7 million, we make a rough estimation that the people that they are older, and based to the statistics in Greece, this is a 40% of the 7 million. But among this 40%, that is like the people of people older than 50 years old, only the 60% of them, they accept to be vaccinated, because I don't know if this is a case in your country, there is a lot of hesitation for people to go and vaccinate. So from them, from this number of the people, they vaccinated with a daily rate, let's say, of 100,000 vaccines per day for the whole country. We are going to reach a specific number with this rate for this number of the people. Then we move to the other 60% that we have included the rest of the people that they are vaccinated younger than 50 years old. the acceptance in this kind of ages is much higher. So it's not 60%, it's around 75%. This makes another with 120,000 rate, because as Despina has mentioned, as the days are passing, the vaccinate rate in Greece is getting to a higher and higher value. So probably this is like an average figure. And this will make us a calculation what kind of number we are going to have in, let's say, in a month from now, let's say. And this will give us an estimation if we have reached the 7 million, or how much time do we need more in order to reach this 7 million of people to be vaccinated. This is somehow, the case. That
okay, so you tried to use mathematics to predict the progress of vaccination,
yes.
and yes, and probably that could be used. So you tried to think in the problem of predicting the demand on vaccines, and probably to predict how long it will take for many reasons, like
yes.
I don't know, for opening up the society, etc. So yes, this is a valid problem, probably. Of course, if we had time and this was a project, we would need, to go further into researching. We could find numbers on the population. We could also see how, what methods, because I guess the right now, governments and the state uses already some methods to, do that. So what kind of methods they use and how can we improve that? Thank you very much, the Greek team. Any other? I know that Rodrigo from Spain has written here, if you allow me to do that. So Rodrigo says any data set can be fitted by appropriate functions using ICT tools in order to use it as a forecast for future. This is the key of modelization. And yes, and the mathematical models have been used also to predict the, how the virus also affects the population, the how it evolves, etc. Yeah, any other group who would like to say a few words?
Aviv, would you like to present our work?
Yes, I will. I'm Aviv.
Hi, Aviv.
Pleasure listening to you all. I'm a student currently in the second year, and we were discussing about Israel situation in the COVID, since we are mostly vaccinated. We would like to tackle on how we can enable tourism and traveling with the least restrictions possible, because no one wants to travel and end up in a country where he needs to be quarantined. So we were thinking about building a model about how likely it is to a variant being spread based on the country of origin, and how many people we can get into Israel so they can travel freely without having to be quarantined, and how many people we can let out. So we could modelize and characterize each destination we would like according to a set of parameters, and see how likely it is to have a new variant or something we can't deal with. So we can make quantities of people who can come in and go out freely.
Yes, great. So you talked also about it's maybe logistics also. I don't know. It's not my field, but it's a kind of distribution also. How we distribute population in specific areas in order to still be safe for these people and for the local population, but still accept movements of tourists in the country, if I understand well.
Yes, and this is a general problem, because in 2-3 months, Europe will be vaccinated, the United States will be in a month, and so but the rest of the world, it will take time until the rest of the world will catch up.
Yes.
So then the question is, how do you manage it when there is a chance for mutation, and there is mutations, and there is a chance that they will invalidate the vaccination. So all of these questions are relevant.
Thank you very much. I don't know if I have time for maybe the other teams, if they would like, they can write in the chat, and then I can continue because I still have a few slides. I hope this is okay with you.
If you have time, 12:15.
Okay.
Okay.
Okay, 12:15. Then I do have time. Any other group who would like to discuss a bit? Remember that this was a brainstorming session on finding a problem, not finding also the solution. So I don't expect, you know, a solution also like, okay, we will do the model. This is how the model will work. It's just, you know, brainstorming on a problem. You know, that we could solve. We don't really know when we are brainstorming. We don't really know the solution. We don't maybe even know the existing solutions, but this is the next steps. So, you know, we brainstorm, we find a problem, and then we try to become wiser, like on the problem. Yes. And maybe this is not a problem, but then we can, you know, redirect maybe our focus to a similar problem. Or a branch of the problem. Any other group?
I will say that mathematics, I mean, until, you know, someone will appear, like, you know, mathematics, like in the way that, you know, this problem-based learning, you know, analytics, you know, do they work? It's like what we have now right now, machine learning, and, you know, how the artificial intelligence operates. This is, you know, models and, how can I say, models that they follow a feature that trains the machine, all right? So it's like something training that it's with us.
Yes, and of course we could have problem-based learning with other disciplines. So maybe the focus wouldn't be on mathematics, but for this workshop, for this session, of course, the focus is on mathematics.
Like what is consulting? Consulting is a problem-based learning. Like consulting, you know, those that they control the economy, the consultants is like, what do you present? It's like an application of PBL, no?
Yes, yes, one could say so. Okay, so we have, I think, from Kosovo, timing of infection can be disputed with probability density in function. Yeah, so I think this is also for predicting the infection rates and how I hope I understand well. And how this could evolve over time. Yeah, that's also a very valid problem, I would say. Okay, I will continue with my presentation, but if you want, please type your problem, and then we can start. Can you see my screen? The slide?
Yes.
Thank you. Thank you. I don't have the, yeah. So I have here some examples, of course, like I'm in no way expert on this field, by the way, in COVID-19. Of course, because my field is more on education and educational technology, we have had many discussions about how to anticipate that. But by just, you know, Googling, just, you know, a few things on the internet, I found, for instance, this site which has an interactive actually visualization on some, you know, let's say domains among COVID-19, like impact on travel and trade, treatments, new variants, the media's role. This could also be relevant, you know, how do we, I mean, for mathematics, it could be maybe algorithms that filter, you know, fake news or stuff like that. For other disciplines, it could be, you know, how we inform people, as also the Greek team proposed. No, mentioned, actually not proposed, but mentioned, many people are still reluctant to vaccinate. What can we do about that? Public policy governance and COVID-19 is another, you know, domain, the virus and the disease, economic impact of COVID-19. That's also very important. And, you know, we could also think about things and that we could try, you know, to or problems we could try to solve there. And then seasonality and weather. developing and distributing vaccines. So one could say, okay, I want to employ mathematics to improve logistics of distribution of vaccines. So is this a problem? Again, I don't know. I just have, some brainstorming ideas. And what our students usually do is they develop some concept maps, as for instance, this one, and then they try to, sometimes they select what is also very interesting for them. And then they try to dig, to go deeper on each of these domains and find out, is this really a problem? Are there any existing solutions? What can we do on our side to contribute? Mathematics and technology, another problem, to gather data on migration. For instance, we had a cooperation with the UN Refugee Agency, and they told us that because now people, that gather data cannot travel to the specific refugee camps or places where refugees pass, they have issues on gathering data on people moving. So one could think also what can technology do, for instance, or algorithms or models to also support that. Mathematics to develop algorithms for monitoring, supporting students in online blended education. It's also something else that one could think of. So these are some very, let's say, abstract problems. And then, of course, by doing the problem analysis, as we saw, we could, go deeper and select a very specific problem to solve. Yes, so I have here a video of a student project. I don't know if we can have a look. So you have an idea of another project. It's not related to COVID.
For our fourth semester project, we contacted the administration at Aalborg University Copenhagen, and they told us about their problems with the students and employees smoking in front of the main entrance and throwing their cigarette butts on the ground. So we thought it would be a great opportunity to work with a real-life case and use the theory of nudging in practice. The behavior back then created passive smoking and a bad smell at the entrance, while also causing an economic expense for the university. First, we observed the smokers' behavior to understand why the smokers didn't use the ashtrays and didn't stand in the area where smoking was allowed. From the analysis of the observation, we found that the underside smoking behavior was caused by misleading signing and that the smoking area was simply not defined. We used nudging to solve this problem. Nudging is a method that gently pushes people's behavior in a predictable way. We then started to design nudges based on known nudging strategies. After implementing the different types of nudges, we went back to observe to find out if there were any change in the smokers' behavior. And the observation showed a significant increase of people having the desired smoking behavior after the implementation of our nudges. Our learning process approach was based on problem-based learning, and this tool let us research for nudging strategies that could be applied in order to solve this specific problem.
Okay, so here we can see how some people who, study a specific topic, they have tried to apply the nudging theory, which is a theory, from their discipline, in order to solve a real life problem. So, and I can definitely agree that this was a problem for our buildings. And I can also tell you that the nudges that they created, like these signs and then signs also on the floor, still exist. And there has been a significant change on where people actually smoke. So this just to showcase, another student problem and how they used a real life example to, to learn actually to apply theory, the theory of their studies. Now, in the last part of my lecture, as I said, I would like to discuss about some skills that we try to teach our students. According to the feedback of students themselves, they said said that what is important for project work, it was project planning and management, discussion, meetings and management, proper academic approach, handling demotivation, communication, group roles, and conflict management. So in this lecture, I have highlighted the things that I will try, of course, to touch a bit superficially because of the limited time. So project planning and management. What we always obviously advise our students, and everyone who has worked in a project knows that you need, first of all, to have software to support. It can be also a physical calendar in your office or your group room, where you explicitly have milestones, you have the tasks and the deadlines, and it can be also Trello for doing that, of course, digitally, and regular meetings also to really monitor the progress and also address any issues that come up. And the thing is that it's not as easy as it sounds when I'm just explaining, because when we are carrying out a project, we always have to adjust the time, the quality, the cost of producing like the output, and the scope of the project at the same time. So we have, for instance, to see, okay, how much time do we have left? Shall we maybe lower the quality, or maybe the scope? Shall we limit the scope in case we run out of time? What it will cost us to do that, and how this relates to the quality and the scope. So these are 4 different factors, let's say, that we always all the time have to adjust and adapt ourselves. So it's a very complicated process to do. And the other problem that we always have in the project is what we call the paradox of planning. So the importance of the decisions we take in the initial stages of a project is actually when we take the important decision where actually the available information and knowledge we have on the project is in its minimum. So as you saw before, you select to work with a problem, you try to design a solution, or even you try to select the right problem to work. And then, for instance, you later on, when you try to develop the solution, you realize that, for instance, some decisions you took were not relevant, or it's not possible to implement. So and that applies to all the projects, because of course we have an idea of what we have to do, but embarking in the project always give us more information on the process, and we have to take important decisions when this information actually is quite low. And although the process to work with a problem I presented to you looked a lot like the waterfall method, anyhow, anyone who has worked already in projects knows that things do not work like that. But usually you are going through several iterations. You implement something, you test it, and then maybe you realize you have to adapt. So actually you go back and you redesign maybe, or re-implement, etc. So that's why nowadays many people talk about agile methodologies in project management, even in education, which is actually focuses on cumulative outcomes. So trying to build, let's say, small parts of the whole output in iterations, and not, focus on providing the whole thing at the end, as it was the case with the waterfall method. Now, that was on project management, communication for cooperation. So what our students actually do when they enter university in the first semester, we ask them to take a few tests. It's not actually anyhow to, the results are their own results, so we don't really, register the results, but we try to make them a bit more aware about their preferences when they work with others, when they take decisions, roles, and also on the team roles, so which roles maybe fit them better in within a team. And also we try to make them, as we say, active listeners. So when someone expresses a problem or an idea, how are we really, listening to this person without maybe guiding the conversation to where we would like, to guide the conversation to, or imposing or trying, maybe sometimes even without realizing, trying to impose, what we think it's right. And then the Myers-Briggs actually type indicator is a questionnaire, is a set of questions, and in the end you get one of the 16 personality types, but it's, as I said, it's not about skills, abilities, or intelligence, but it's about preferences. So if you see there is, how do you prefer to take in information? How are you outwardly or inwardly focused? How do you prefer to make decisions? And how do you prefer to live your outer life? So it's about, our lifestyles. It's about the way we communicate, and there's no right or wrong, but it's just of becoming aware what our preferences are, and then if all the others are aware, then we know why we do the things we do. So it's, as I said, to understand yourself, to and use it in the group work and collaboration. So also to say, this is how I prefer the information. Maybe you're different than than me, and that's also okay. So in order to make people aware of preferences of their own and the other people preferences. Then for team roles, as I said, we use the Belbin team inventory. So we have different roles in a team. Usually we only think about on the project manager, but we try to move away from these roles, and maybe think about like the team worker, the implementer, the completer or finisher, the specialist. So there are different roles, and we invite our students to see, okay, where do they see themselves when they work in a team. And of course we encourage them to, when they have a group, to try and have as persons from the different categories, because if you have a group where all the people are coordinators, then it's going to be difficult to work within this group. Now, active listening, it's actually it's as I said, a method to listen to others and to pose relevant and exploring questions rather than leading questions, and also show respect for the opinion of the person talking. So one exercise you can do actually, and our students do, when you are in a group and you work in a group, is the following one. So you can take turns, and one brings an unsolved personal issue. It can be something, I don't know, in the group, something that they face a challenge, or a personal issue, like something, I don't know, with your girlfriend, your boyfriend, your mother, I don't know, something on your work. And then we have the presenter, which is the person explaining the problem. We have the active listener, and we have the observer. The observer is the rest of the group. And then the presenter presents a problem, and then the active listener tries to apply active listening to, as I said, not to pose leading questions, but maybe explorative questions, in order to understand the problem, not providing solutions. By the way, this is very, very difficult. And I think you may have experienced that whenever, for instance, a friend comes with a problem, because we love we want to support this person. In some cases, it's a person we love and want to help, and we always try to find a solution. But active listening is not about finding solution; it's about giving the space for the other person to express the feelings, express the problem, and that by itself, it's actually very accommodating and supportive. Now, the team player. So what is the profile. So the team player, so the groups, the member of a group, they should enhance the discussion by proposing things, not imposing, seeking information through questions, as we said, active listening, providing information when needed, summing up the discussion is also a very good, way when we are talking. So it's very nice that there's at least one who says, okay, let us summarize what we have said so far. Expand proposition and ideas when possible, and testing the understanding of both own and others' idea. Because I don't know if you should have experienced that for sure, talking to others and then, at the end of the discussion, realizing that you had an idea of, the topic of the discussion, and maybe other people had their own ideas. So it's very important that we test along the discussion and along the teamwork. Are we on the same page? Are we still on the same page? And it's more difficult than you can imagine. And then our students get some, tools also to work on conflicts that may happen within the group. So, for instance, here is a representation about the different conflict management strategies. So this model actually tries to map the strategies along the concern for self and the concern for others. And for instance, if I'm very concerned about others and I just, push away my own feelings and my own needs, then we call it accommodation. If I ignore both the others and myself, I'm avoiding, it's the avoidance. We have competition if the concern for self is, much higher than the concern for others. Compromises where these two are, in the middle. But the collaboration actually happens when we have a high concern for self and at the same time a high concern for others. So it's this, that's why the team worker has also all these qualities. And another way, when a conflict appears, we also try to teach the students how to talk about the conflict and how to communicate with each other. So we have, and I can tell you that this is something even the teachers teach at primary schools here in Denmark. So, and I can also advise, can only advise you to try and apply this also in any other conflict you may have, not only in group work or at your work, but also in personal, relationships. So we have two approaches, to present a problem, a conflict. One is the I approach. The I approach focuses on how you feel or your experiences. So you can say, I feel very stressed because I feel that we are really behind with our schedule, and I don't know. In this approach, it's the I approach, and we call it the giraffe language. So it's the nonviolent communication. So this was imposed by, proposed by Marshall Rosenberg, by the way, if you want to learn more. So in this approach, we don't interpret other people's motives. So we don't say, and we don't attack people or blame people for what is happening. So if I say, you are not contributing to the group, so we are not progressing well, this is attacking. Yes. If I say, I feel that we are behind, then I just talk about how I feel, and I'm not, blaming or interpreting that you are bored with a project and that's why we are not progressing. That's interpreting the other people's motives, which I have actually no clue about. And don't dictate what anyone else are to do. So don't say you have to do that because I'm stressed, but you focus on, as I said, what you experience and what your feelings are. The other way, which only causes problems, and we try to teach our students to go away from it. It's what we call the jackal language, which is opposite to the giraffe, and it's the you approach instead of the I approach. So in the you approach, we state the way others feel about or experience things. It's like you are bored and you are not contributing. You are not, I don't know, you don't work as much as you should. And then we interpret other people's motives, we blame or degrade other people, and then dictate what other people should do. So you should work more, you should contribute more. And that, as I said, applies to any conflict arising in your life. If you try to do that, you will see that the I approach for sure will be more successful in avoiding, the conflict to become bigger when we actually discuss the conflict. And as a last part for the group work, we always advise the students to actually have a collaboration agreement, which is something that I can only recommend with any, within any group or collaboration you have, where you state what happens if this is not upheld by the members, can we exclude members, what is, the communication tools, the protocol and all that. And as you see, there are different aspects to take into account, but I think I'm very close to the end of my talk. So I mean, we have found out along the years that actually our students learn how to apply, first of all, theory into real life problems. They learn how to adapt an academic way of thinking and working, and also they improve their collaboration, their project management skills, the negotiation skills also, and they develop a strong sense of and culture of collaboration and teamwork and high level of support for one another. So with this one, I would like, part of this is part of the course that my dear colleague Jon Ram Brun Pedersen actually teaches to first year students, and I would like to thank you very much, and I would be happy to answer any questions.
Yeah, Eva, thank you very much for your talk. The topic is so interesting, and I think you can talk about the whole day about this. Very few and interesting points. I see some hands raising. Evangelius? Please, you're muted, yeah?
Clap. Okay.
Thank you.
Hi, very much, Evangelia, for the nice talk, and Kostas and Nisim before. I don't want to ask something. I just clap for my hand. Okay.
Thank you, Vangeli. Thank you.
Okay. But George?
Good morning, Chris. Thank you all for your participation. Thank you, Evangelia, very much for the nice talk. I have one question. In the beginning of your presentation, you informed us that each project formulates an umbrella under which 3 courses are included. Is this the total workload of the semester? Meaning that one project is the complete workload for the students for this semester? Thank you very much.
Thank you, George, for your question. The total workload is a project which amounts to 15 ECTS, and then we have 3 courses, 5 ECTS each. So the whole workload amounts to 30 ECTS per semester. So the students attend 3 different courses, which is actually also have their own exams, maybe their own assignments, mini projects, and then in parallel, they work also in the semester project.
So 30 ECTS
yes, in total.
From which half of the workload corresponds to the semester project.
Exactly. Yes, of course.
Evangelia, can I ask something on this?
Yes, of course.
On total of, let's say that you have over the 100% of the students, how many of them they have the option to follow the project plus the 3 courses? and how many of them they have the other options to follow, let's say, 5 or 6 courses in order to complete the 30 CTS, or it's an obligation for
yes.
all the semester students to follow this scenario?
Yes, it's mandatory for everyone.
How many groups do you create? Because how big
it depends on the studies, on the studies, how many they intake, because some studies accept like 100 students and some studies accept only 30, like in the master. But usually when we have big generations, we have up to 7 students per group. So if we have 100 plus students, we used to accept some years 200 students almost, and we still have 7 students per group. So we don't go more than 7 and not less than 4.
And the supervision belongs to, there is a supervision.
Yes.
You have assigned for yourself, for example, a number of groups that you should supervise, no?
Yes, depending on your teaching duties, you have some teaching hours and some supervision hours. And in the supervision, we also engage research assistants and PhD students, because PhD students have also to teach for some 800 hours in 3 years. So part of this is supervision of groups. Yes, so it's a part of your duties as a teacher, yes.
And this configuration, did it work in mathematics? Because in Nissim mentioned something like the people they cannot communicate, using, if they don't have the tablets. How do you how you have applied this configuration during COVID-19 in mathematics?
I mean, I don't know for mathematics, but I think it applies for everyone, also for our own, studies. I think obviously the communication has been affected by the online mode, and the students really were looking forward to come back to the campus. But what they did is they do have tools. So our students, every student has to have a laptop, for instance. It's a must. You cannot, enter university here without having a laptop. So what they did is they use like Discord. They use different environments to communicate.
Yeah. I learned this from my students, Discord.
Yes,
I feel like I cannot, work with them through the Discord, but they work very nicely with Discord.
Yeah, we are not allowed from the university to join their Discord rooms for GDPR reasons, but the students do that, although of course they are discouraged, but I think they prefer that. Yes, of course, you're welcome.
However, Nissim mentioned about, do not have just a laptop, to have, a tablet that you can write on it, like, Surface or iPad Pro, something like this.
Yes. I mean, yeah, there are nowadays ways you can also make screencasts for your students if you're a teacher quite easily, even with free tools. And this is what some people do.
Or Bamboo is a nice option, lower cost. Like Nissim, you're using Bamboo, I think. You're not using Bamboo? You are using Bamboo. In one of the meetings, you are using Bamboo. This one?
No. I'm now using a X-Journal.
Okay. Yes. Okay. There are.
Yeah. Yes. There are ways, even if you still want to do it, pen on paper or. Yes.
Okay. Are there any further questions?
I would like to highlight that in Aalborg, this way of teaching is an obligation. It's like a policy supported by the university. And Evangelia has mentioned to one of the only one workshop that we have managed to do in the item face-to-face, the last one, that it took for them, like more than a year in order for the students to accept as an activity. So if you would like to apply it, you need to have you need to be patient. And also to have the support of the university.
Yes, applying that in all semesters, and it of course requires an institutional strategy. But you can also have some PBL modules within courses if you would like, where you towards the end of the course you may have a PBL course or along the way. So there are ways also to sneak in some PBL if you want in individual courses, because individual is institutional strategy, of course, requires a lot of resources, a lot of decisions, a lot of time, you know, because people are not flexible into changing. So and that's why today for the students especially I tried to highlight some, you know, of the qualifications you would need to work on PBL that you can also apply in every other study and discipline. Yes, because we collaborate anyhow with people and with students and teachers. So yeah. Thank you very much for your attention.
Thank you very much, Eva. I think you are here for the next time. If there are any question, they can write it in the chat. Personally to you, I think it's okay for you.
Yes.
Okay. So then I would like to continue, or we would like to continue with our next session. Adrian, Maria, and Mats, you are here. Can you hear me? Hello?
Yes, yes.
Maria, I can see her. Okay, Adrian is also here. Okay, okay, yeah, welcome. Yeah, now I will introduce our next session. It is given by Dr. Maria Falkgren. She is here, and Dr. Mats Brøndstrøm and Dr. Adrian Muntean. Their topic is mathematics in amusement park. So I'm very interesting what we are learning here.
We need to have a break before. Just.
So, okay.
Sorry, but would it be possible to have a break until we start? I think we have.
Do we want to have 5 minutes break?
Yes, I think it's valuable for all the participants because we have sitting so long time and break. So
we will have 5 minute break. Okay,
yeah.
5 minutes enough, or do you want to make more break?
It's enough. Yes, it's enough. It's enough. Yes.
It's enough. 10 minutes?
Yes. 5 minutes.
Okay, we are back in 5 minutes.
5 minutes.
So,
yes.
Yeah. Okay. Yeah. Maria?
Yes.
Hello.
Hello.
Nice to see you.
Thanks.
Okay. Do you now have the co-host permission? And
I'll check that.
check it. So I prepared breakout
No,
rooms.
so not yet.
Not yet. So Kostas, can you take a look if it's possible to give Maria some co-host rights for the
Yes,
presentation?
I'm doing right now.
Okay, and I prepared the.
No, I cannot do. Look, I
No.
have made you host, Renate. So it's
Yes,
you.
Ah, you're only allowed to. Okay.
So if you give me back my host right, I can make it. Otherwise, you can do it by yourself.
How can I do this?
So go next to the name of Maria. They says more. You click, and then you make Maria co-host. Otherwise, give me the host back.
The co-host erstellen. Yes.
Exactly. Thank you. Danke.
Okay.
Yes.
Thank you.
Now I'm
Okay.
co-host.
So
it
you're
works.
both colleagues.
Yeah.
Do you also need co-host?
No, I don't think so.
Okay.
No.
Okay. So then I.
So sorry, Renate.
Hi, I'm
It could be that I would have to move between the breakout rooms. So I'm not so sure if I, as a participant, can I? Probably yes.
No, you can't.
Then it would be good if you make me also co-host. I promise not to do anything else.
Yeah.
Like
okay.
closing the session or so.
Yeah.
Thank you.
So,
I'm feeling.
Genau. I forgot how long should the breakout rooms be from the time? 10 minutes or more? You said 30 minutes?
About 30 minutes.
30 minutes. I do 30 minutes, and you can also give me a signal, and I can bring them all back. Okay.
Yeah, great.
And you said 5 to 6 per each room, huh? That was,
Yes, we will provide instructions. Yeah.
Yeah. Okay. So I don't know how it works, but we will try it.
Yes.
Okay.
Yes.
If you're ready, you can start. Yes. Welcome.
Yes.
Yeah. Here to see you, and yeah, it's an interesting topic. Yeah. Amusement park. So, Maria, your microphone is muted, but
yes. So I take it over from here a little bit. So hello everyone. I have a full admiration for you for resisting so many hours online without breaks. I truly hope that while you switched off the video, you had some breaks, because otherwise it's inhuman. So amusement parks, mathematics in the amusement parks. Well, if some of you are mathematicians, of course we have we do mathematics everywhere, including in amusement park. But if you are in an amusement park, you don't have to be mathematicians to feel a bit of mathematics challenges. Let me ask a rhetoric question. Why do we go to an amusement park, right? To feel something unusual, to get an adrenaline kick, to, as you look in this roller coaster in this picture, is maybe to feel a zero gravity situation, right? Or to feel a force which is twice as strong as the gravitational force acting on you, or maybe 4 times as hard, maybe if you are looking for extreme situations. So this is more or less the topic of this afternoon, not afternoon, of this next 40 minutes. I'm just a kibitzer in this presentation. The real heroes here are Maria and Mats. Maria, you met, maybe you can say once more, hi to everyone, Maria.
Hi.
And Mats, would you please say also hi to everyone?
I have to unmute myself. Hi, everyone.
So you saw them, Maria and Mats. So they will tell you what we have to do, and I will try to join the breakout rooms and work together with you. But before going into the next slide, just look at this roller coaster shape of the path. You see, it has a very sudden change in curvature. So acceleration will change dramatically from one part to another part. So it's interesting, I would say. And yeah, kids like it, we like it. And this brings me to the next question, and also to the next slide. Sometimes they are broken. I don't speak here about accident. The unhappy chance that you are in the probability that you are in an accident with a roller coaster, in fact, it's much smaller than you would be hit by lightning. So this is not the purpose of this discussion. The purpose of this next, say, 35 minutes or 40 minutes discussion comes now in the next slides, where Mats or Maria will tell you what's the problem.
Yes. So here is the task that we want you to engage in during the next 30 minutes. The task is parts of a structure in a roller coaster need to be replaced. It's the part between points A and B, see the figure below, and that needs to be replaced. Your task is to determine two different functions that can be used during construction so that there is a smooth transition in points A and B. So you will have this task quite soon, but first we want to discuss some practical issues, how to organize this work, because we encourage you to collaborate on these tasks. And we think it is most appropriate if you are from the same country, so you can use your the language you are familiar with. But it's not, you don't need to, but we have prepared breakout rooms for each country. So you join as soon as the breakout rooms are activated. You will see an icon below at your screen, breakout room. You click on that. If you attended the previous session, you have already practiced this. And there you can enter a room. You can choose the country which you want with the number. And since we don't think it's so great to be too many to be able to collaborate, we think that if you are 6 or more in one room, we ask you to split the group. It's better to be 3 or 4 working together. And in each breakout room, one of you share the screen, and we will provide you a link in this breakout rooms to the task. And when you enter this link, it looks like this. Mats will show you.
Yes, I will now enter the link. So the first thing you will do is to log in. And we want you to use the name of the breakout room. So for instance, I am Sweden 3. I write Sweden 3 and then I start. And when you come into this room, you see the task once again and some further instructions. So you should use the measurements in the sketch to the right below. You should use GeoGebra, I will show you soon, to check if your suggested function formulas are suitable or not. So you can give it several tries to find the right function. And when you're convinced that your function fulfills the required conditions, you then should drag the function formula into the graphics view I will show you very soon. And then you will proceed to the next task. So here we have the task. And here you will try to find a function fulfilling these conditions. So if I, for instance, think that y equals 2x plus 5 will be a suitable function, then I submit it. And I see that that's not a good function. I will try something else. So we discuss in the group and we make a new try. 3x plus 1, perhaps. And when we think we have the right function, we should take this formula and drag it into the graph. And that can be a bit tricky. When I do it, it succeeds every third time or something like that. So it didn't succeed the first time. I try again. Not the second time. And I don't know what the difference is when it succeed and not succeed. But finally, it usually do. But probably not now. So if you can't do it, just skip it then. But give it a try. Okay, when you have found one function that you're satisfied with, you try to find a new function. Can you find a different function that also fulfills these conditions? And do the same way. And if you have time, you can go to these generalization tasks, because in the first task, we said that it should be 10 meters and 15 meters, these horizontal and vertical distances. And if you have time, you can try to generalize. If the horizontal distance instead has the value A and the vertical distance has the value B, can you find a formula that fits for all values of A and B? So when you then submit a function formula, x plus, ax plus b, for instance, then you can change the parameter values. So the value of a you can change and see if it works for all values of a, and you can change the value of b. So that's the generalization tasks. And if you still have time to work on this, you can go to the last task. Try to find another unique function which you think no other group has come up with. So that's the last task. So let's move back to the instructions then.
Yes. And so you use your name of your breakout rooms when you're entering the task. And can you click the next? If you get stuck and need some hints, you can leave the breakout room and meet us in the main room, and we can help you. We provide some hints. Oh, and we will end the session about 50 minutes to discuss what you have come up with and also sum up the session. So from now on, we encourage you to discuss, be creative, and enjoy. See you later.
Okay, I open now the breakout rooms, and
yes.
I think everyone is clear. Thank you for your explanations. Okay, so the breakout rooms are now open, and you can see here different rooms. Kosovo, we have The most people are from Kosovo, Greece, North Macedonia, Israel, Uzbekistan, and then I create 3 other rooms. For example, we have only one from Ukraine. Can you see it, Maria?
Yes, I see.
Okay.
And I have posted the link to the task.
Κωνσταντίνε, πάλι μαζί είμαστε.
Καλημέρα σε όλους.
Ο κύριος Φωσκητάκης, τι κάνετε?
Καλά είμαι, Δέσποινα Γιώργος Σκέτο, άσε τώρα τα κύριος. Τι κάνετε, καλά είστε όλοι?
Δόξα τω Θεώ, όλοι καλά είμαστε.
Πάντα καλά, πολλούς χαιρετισμούς.
Θέλω να ζητήσω λίγο συγγνώμη, θα συμμετέχω κανονικά, είμαι στην κουζίνα και είμαι μεταξύ αυγών και μεσημεριανών.
Και εγώ τηγανίζω πατάτες, μην νομίζω.
Τι να κάνω, εδώ έχω και έναν αντρικό πληθυσμό που πεινάει. Συγγνώμη, Πετρίδη, άνοιξε, είσαι unmuted.
Πεινάω.
Πεινάς. Κάνω φωκάτσα, πώς λέγεται.
Κάτσε να βρούμε το link που στείλανε. Πού το στείλανε το link?
Μήπως στο chat, θα πρέπει να μας το στείλει πιο πριν.
Δεν το έχει στείλει στο chat.
Στη βασική...
έπρεπε να μας το έχει στείλει από πιο πριν.
Στο βασικό το έστειλε πριν μπούμε στο...
Αλήθεια, το έκανες αυτό?
Κάτσε, βγαίνω και ξαναμπαίνω.
Βγες εσύ, ωραία.
You have to create a new Israel too.
Yeah, how can I do it? Maybe can...
You can't create in retrospect.
No, I can't create it. But they can split up in other ones.
Yeah.
Can you send us, the link in GeoGebra on the chat in order to be...
Yes.
Copy it and go back to my room?
Is it gone? I posted it, but I...
If you write it down on the chat, it will be
to
easier.
everyone. Everyone.
Is it possible to get the link
Yes.
to the GeoGebra?
Of course.
Okay.
Yeah, thank you.
Nisim?
Yes.
You are many people there. We will have to split you, so don't get in panic.
No.
Just to tell them that there will be split.
We are 6. No, we are not.
Yeah, but we are going to be less, 3.
Μέχρι στιγμής, δόξα τω Θεώ, τα παιδιά έχουν ελευθερώσει.
Έχουμε Ευάγγελο κόκκινο, δεν φοβάμαι τίποτα, θα φτιάξει τη γέφυρα.
Έλα, γιατρέ μου.
Ελάτε.
Εγώ θα ανέβω την ανηφόρα γρήγορα με το ποδήλατο.
Αυτό πιο πολύ φυσική μου μοιάζει, που χρησιμοποιώ παρά μαθηματικά.
Τώρα η μηχανική, πού η μηχανική τώρα. Όποτε είναι η μηχανική, όποτε είναι να φτιάξουμε κάτι φυσικά, γιατί στην Ελλάδα δεν φτιάχνουμε τα αρχίδια. Συγγνώμη τώρα για τη σύγχρονη.
Ναι, εντάξει, είναι και μηχανικός γιατί το κατασκευάζει. Τέλος πάντων, για να δούμε τώρα τι
αυτό είναι το link. Το πήρα.
Ωραία, ένας λέει θα το κάνει.
Ωραία. Λοιπόν, Βαγγέλη, lead τώρα, παιχταρά μου.
Για μου είναι στη μαγειρική, δεμένη είμαι.
Εγώ ήρθα παιδιά πρώτη φορά στο γραφείο. Ακούς, ήρθα πρώτη φορά στο γραφείο και πάρα ανέβω. Και μια γυναίκα φύλακας και μου λέει τι θέλετε. Λέω εδώ δουλεύω, λέω. Μου την ψάχνει.
Δεν σε ξέρει γυναικείο.
Δεν σου κάνει αυγοκαλρική.
Όχι, αφού ήρθα και δεν ήξερα ότι δεν θυμάμαι το password του υπολογιστή, γιατί το έκανα συναίσθητα και μου πήρε ώρα μέχρι να το ξαναθυμηθώ. Το σημείωσα.
Ρε παιδιά, το link δουλεύει σε εσάς.
Εγώ μπήκα, ναι, δουλεύει το link. Απλά δεν θυμάμαι τι κωδικούς βάζουμε για να μπούμε τώρα, γιατί...
Αχ, είπε της ομάδας. Της ομάδας είπε. Φαίνεται η ομάδα μας τώρα. Γκρίς ήτανε.
Κάτι ένα share screen ο ένας. Ένας χρειάζεται να μπει.
Παιδιά, συγγνώμη, αυτό το link που έχει εδώ κάτω τώρα, αυτό δεν πήρατε.
Ναι, αυτό πήραμε. Αλλά Γιώργο, άμα το έχεις βάλει εσύ, κάνε share screen, να βλέπουμε το screen σου, να δουλεύουμε από εκεί. Δεν χρειάζεται όλοι να μπούμε.
Ωραία.
Είπε όχι όλοι, ένας.
Share screen.
Μωρή, Βαγγέλα. Αρρώστια.
Σε αρρώστια.
Το βλέπετε τώρα.
Ναι, μια χαρά. Για πάτα, join.
Ναι, join, αλλά με τι όνομα.
Γκρίς, το έχει μου φαίνεται.
Γκρίς, ναι.
Το έβαλα γκρίς, δεν μπαίνει.
Ας το βάλες.
Γκρίς 01 ή 02.
Όχι, δεν είχε νούμερο.
Κάτσε να ξανα... Βγήκε ο...
Τι έγινε, παιδιά?
Τι κάναμε τώρα, μείναμε οι δυο μας.
Μας πέταξε έξω.
Μας πέταξε έξω.
Ναι, τώρα πρέπει να ξαναμπω στο breakout room. Κάτσε να δούμε που είμαστε. Γκρίς.
Μπήκε και η Ευαγγελία μαζί μας. Άντε ρε, μας χώρισε ρε, μας χώρισε ρε μαλάκα ο Τσαουσέσκου. Μας χώρισε ρε μαλάκα ο Τσαουσέσκου. Μας έβγαλε τώρα ο Τσαουσέσκου. Τι έγινε ρε Ευαγγελία. Θα τον δίνω αυτόν τώρα ρε μαλάκα. Η securitate. Ευαγγελία, τι γίνεται, τι λέει?
Καλά, τι να γίνει. Δεν έχω ίντερνετ. Ξαφνικά, ακόμη και στη Δανία συμβαίνουν αυτά. Δεν έχουμε ίντερνετ, τώρα είμαι από το τηλέφωνο, με hotspot.
Μαλάκα, εδώ πέρα, ούτε στη... Αυτό δεν το περίμενε στη Δανία να γίνεται.
Κι όμως, γίνεται και στη Δανία. Και έχει και μέσα σχολείο.
Πότε μου το έχει πει, εσύ μας το έχεις πει ή ο άντρας, ότι είχαν μπουκάρει και στο σπίτι σας στη Δανία. Που πάλι αυτό, ούτε αυτό περίμενα.
Κι όμως.
Γιατί βλέπω εκεί πέρα τα παραθυράκια ανοιχτά, λέω, δες εκεί πέρα, λέω, ασφάλεια.
Έτσι νομίζαμε και εμείς.
Και μπουκάρανε, Μάθες τι θα γίνει με σένα τώρα, μας έλεγες για το συμβόλαιό σου, μου το είπε και ο Βιδάκης.
Ναι.
Δηλαδή, και πότε θα σας πούνε, εγώ νόμιζα ότι ήσουν μόνιμοι εσύ εκεί πέρα.
Όχι, καμία σχέση.
Ο άντρας σου δεν είναι μόνιμος?
Ο άντρας μου, ναι. Μόνιμος αορίστου είναι, δεν έχει εδώ μονιμότητα.
Εδώ δεν έχει μονιμότητα, εκεί δεν έχει μονιμότητα, δηλαδή καθηγητής δεν είναι μόνιμος.
Αορίστου, είναι αορίστου χρόνου. Αλλά άμα κλείσεις με το department, μπορεί να σου πούνε συγγνώμη κιόλας, αλλά δεν. Τι να σε κάνουμε. Εγώ δεν είμαι ούτε καν ορίστου, εγώ ήμουν ορισμένη. Μέχρι 4 χρόνια μπορείς να είσαι assistant.
Ναι.
Και τώρα, εντάξει, λένε ότι θα βγει μια θέση, την οποία, εντάξει, θα την προσπαθήσουν να καλύπτει τα δικά μου ενδιαφέροντα.
Το όχι και αυτό, το έχουν στη Δανία αυτό το περιγραφικό, έτσι.
Ναι. Αν και τώρα, ας πούμε, δεν, εντάξει, σε άλλες περιπτώσεις ξέρω ότι σου δίνουν να γράψεις και την περιγραφή. Σε μένα ούτε μου δώσαν, ούτε μου είπαν τίποτα. Εντάξει, μου είπαν απλά μπορείς να κάνεις αίτηση.
Έχεις καλές σχέσεις με αυτούς ή...
Καλές σχέσεις έχουμε. Εντάξει, εγώ να σου πω λίγο, εντάξει, έχω θυμώσει. Γιατί έχω δημόσιο, γιατί εντάξει, ρε Κώστα, εγώ έχω σκιστεί, ας πούμε, και να μου λένε, τον Οκτώβριο μου είπαν δεν υπάρχει θέση. Τον Οκτώβριο ήταν απόλυτη, λένε, λυπούμαστε πάρα πολύ, αλλά δεν γίνεται να βγάλουμε άλλον associate. Και λέω κι εγώ εντάξει, και άρχισα να ψάχνω. Τώρα, επειδή έχω ένα project και έφυγε η διδακτορικός που μου γέννησε, δεν το περίμενα και ανέλαβα το project και είπα μέχρι το Ιούνιο που θα γυρίσει πίσω, δεν έκανα αιτήσεις, γιατί δεν είχα χρόνο, γιατί και αυτό θέλει χρόνο.
Εμένα το λες, εγώ είμαι χωρίς γυναίκα μου εμένα. Εγώ δεν έχω χρόνο να αναπνεύσω, αυτό σκέφτομαι. Αφού σκέφτομαι έκανα συμφωνία με τη γυναίκα μου να μην δουλέψω Κυριακή. Δεν με παίρνει να μην δουλέψω άλλη μέρα. Αλλά αυτό είναι κατάνοια, δεν είναι αυτό... Μου στέλνουν κάτι Γερμανοί με αυτό το project και δεν τους απαντάω τώρα. Δεν απαντάω στα email τώρα. Λέω, κάντε το εσείς, τι με παίρνετε εμένα. Άμα θέλετε να κάνετε κάτι, θέλετε και την ιδέα και να το κάνει κι ο άλλος. Και να μην κάνετε τίποτα.
Όχι. Ναι, όχι, κοίταξε, να σου πω. Και εγώ τώρα τα φιλτράρω λίγο. Γιατί πόσο, ας πούμε.
Με τη δικιά μας πώς πας.
Έχει 24 ώρες.
Με τη δικιά μας πώς πας. Σου πετάει και εσένα αυτά τα email, ξέρεις, ότι θέλω να κάνω. Και λες εσύ κάνε. Αλλά μετά δεν θέλω να κάνω.
Μετά τελικά δεν βολεύει. Ναι, ρε, εντωμεταξύ αυτά τα βλέπω και με ανεβαίνει το δικό μου το αίμα στο κεφάλι.
Δεν απαντάω εγώ. Ή ξέρω πώς απαντάω. Της λέω, dear Katerina, no problem, please do it.
Ναι. Σε εμάς επειδή τώρα δεν έχει να κάνει τίποτα αυτή,
ναι.
Είναι ήρεμη. Αυτή είναι να μην χρειαστεί να κάνει. Όταν είναι να κάνει, αγχώνεται, γιατί μια δεν ξέρει τι να κάνει. Ναι. Αυτό είναι το μόνο της πρόβλημα. Έχει μεγάλο άγχος, οπότε προσπαθεί να κάνει ό,τι λιγότερο και ό,τι πιο εύκολο. Και επίσης, αν έχει να κάνει με λεφτά. Ας πούμε τώρα, εμένα μου έστειλε, γιατί καλά το National Agency το δικό μας, είμαστε πολύ καλοί, διότι κάνανε την κατάθεση και ακυρώθηκε στην τράπεζα. Και περιμένουμε στα λεφτά εδώ και ένα μήνα. Εγώ νόμιζα ότι η δική μας, γιατί και εδώ το financial είναι εντάξει, τσίρκο. Και λέω δεν θα το βρίσκουμε.
Εμάς οι υπάλληλοι αυτή τη στιγμή είναι πολύ καλοί. Αλλά...
Εσάς είναι πολύ καλοί. Εμάς είμαστε για τα πανηγύρια όλοι. Να βγούμε...
Μία έχουμε. Μετά είναι το house.
Ναι, αλλά ναι, μια χαρά κάθισε, σας έκανα αυτά για το item. Εγώ κάθομαι τα κάνω εγώ και της τα στέλνω να τα επικυρώσει. Γιατί δεν βγάζουμε άκρη.
Τέλος πάντων, τελικά τα είχε κυρώσει και εκεί πέρα με θυμήθηκε και είπε τι έγινε με το second installment και της λέω όταν θα το πάρω θα στο δώσω, δεν θα το κρατήσω για μένα. Δηλαδή, τι να το κάνω εγώ. Δεν μου τα δίνουνε κιόλας αν μου τα δίνανε.
Στέλνει αυτά τα ψυχολόγητα τα κοινά σε όλους. Στέλνει κάτι ψυχολόγητα κοινά σε όλους. Τι κάνει.
Ναι, αυτό πάλι.
Εν τω μεταξύ εκτίθεται, γιατί είναι, λες τι δεν καταλαβαίνει τώρα. Δεν καταλαβαίνει τι δεν καταλαβαίνει.
Ναι. Δεν ξέρω, εγώ εντάξει, μου είπε για η συνεργασία, της είπα όχι και γενικά εγώ όχι μόνο συνεργασία, την έχω μπλοκάρει από όλα, δηλαδή ούτε και να τη βλέπω δεν θέλω. Επίσης, με έναν άλλον συνεργάτη που πήρε ένα project.
Της έγραψα την ιδέα, της είπα 1, 2, 3 και την έχω δούλα τώρα. Την έχω σαν δούλα. Το έκανε πριν την γραφειοκρατία, αλλά εντωμεταξύ δεν μου αρέσει γιατί, ξέρεις, της λες συνεργάσου με αυτούς. Δεν συνεργάζεται. Και μετά λέει, γυρνάει και λέει δεν κάνανε τίποτα. Λέω αφού δεν τους είπες τίποτα, αφού ρωτάω εγώ.
Ναι.
Τέλος πάντων, θα τη φαλυρίσει αυτή μόνη της τη δουλειά. Αυτή πάει, δεν ξέρω, εν τω μεταξύ δεν ξέρω τι δουλειά κάνει, με ποιους είναι, τι είναι αυτή η εταιρεία, δεν έχω καταλάβει ακόμα.
Μα γι' αυτό είναι το πρόβλημα.
Είναι παντού, έτσι. Είναι αξιολογήτρια στη Γαλλία. Πώς το διάλογο χώνεται. Στο ΙΚ είναι αξιολογήτρια. Δεν ξέρω πώς.
Χώνεται, ξέρεις τι κάνει αυτή, είναι όπου έχει λεφτά και δωρεάν να πάει ταξίδια, στέλνει και πιέζει και λέει έχει καμιά θέση, ξέρω εγώ, έχει δωρεάν, έχει να μπω. Σε αυτά είναι μάνα καημένης. Αυτό είναι καλό είναι αυτό, στο να βρίσκει άκρες και να κάνει. Όταν να αποδώσει κανονικά δεν μπορεί. Γι' αυτό δεν έχει και αντικείμενο και επίσης δεν έχει και εταιρεία. Ποιοι είναι οι συνεργάτες της, μια Πολωνέζα που τη βάζει και κάνει δεν ξέρω και εγώ τι, με ένα degree από δεν ξέρω εγώ τι, μία στο Λουξεμβούργο δηλαδή, και μία στην Αγγλία τώρα, μια κοπελίτσα που μας έφερε εμάς στο project, ένα μικρό κοριτσάκι που δεν ξέρει τι του γίνεται. Αυτό είναι εταιρεία. Δηλαδή εντάξει. Απλά αυτή σου λέει τα παίρνω εγώ τα λεφτά. Αυτούς τους δίνει ψίχουλα, είμαι σίγουρη, δεν υπάρχει περίπτωση. Ποιος ξέρει και τι τους πληρώνει. Και μετά σου λέει παίρνω εγώ τα 60.000 για 3 χρόνια, άσχημα είναι για Ελλάδα. Και δεν κάνω και τίποτα, γιατί το παίζω τρελή και δεν μπορώ και δεν τα κάνουμε καλά και να με βοηθήσουν οι άλλοι.
Εθελοντικά δεν κάνει τίποτα. Και ό,τι αναλάβει, στη μέση λες εσύ ανέλαβε το, στο 20% στο έχει χώσει εσένα. Και λες τώρα τι να κάνω, δίψα δεν φαίνεται ότι δεν μπορεί. Δηλαδή δεν μπορείς να μην κάνεις.
Ή το χώνει σε όλους. Εμάς μας είχε πει θέλω να κάνω αυτό το στάδιο, οπότε να μου βάλετε όλοι input. Κάτσε ρε φίλε. Εγώ στο δικό μου το στάδιο μου βάλεις input. Ναι, άμα είναι τι πήρες τα λεφτά. Πήρες 150 ώρες, ας πούμε, να κάνεις αυτό. 150 μέρες. Και θα κάτσω εγώ να σου βρω το στάδιο. Τέλος πάντων, εγώ, εντάξει, έκανα το λάθος μία φορά, δεύτερη δεν το ξανακάνω. Δηλαδή σου λέω την έχω.
Αλλά τότε εντάξει.
Εσύ δεν είπες και εμένα. Αλλά τώρα έμαθα τώρα, σου λέω έβαλε και έναν άλλο να μου στείλει, γιατί ξέρει ότι αυτή θα τη γιώσω. Και εγώ έβαλε έναν Κύπριο που έχουν ένα project να μου πει εμένα να μπω σε project. Και νόμιζε εγώ δεν θα καταλάβω ότι τον έχει βάλει αυτή εγκάθετο. Το γύρωσα και αυτό μια χαρά. Του είπα λυπάμαι, αλλά δεν είμαι ανοιχτή σε νέες συνεργασίες. Και όντως, Κώστα, αυτό που έλεγες κι εσύ, εγώ από εδώ και πέρα μόνο με ανθρώπους που ξέρω. Έτσι, στο άγνωστο και να κατεβάσουμε πρόταση και εμάς επειδή περνάνε και γενικά εδώ, ξέρεις, πολλοί λένε, τώρα λέω όχι, δεν θα τρελαθώ εγώ για τους άλλους. Εντάξει.
Έτσι είναι.
Σε λίγο θα με κλείσει στο Δαφνί.
Μα δεν αξίζει κιόλας, να σου πω την αλήθεια. Δηλαδή, τώρα εγώ πληρώνω λάθη που έχω κάνει, αλλά πρέπει να ζήσω με αυτά τα λάθη. Τώρα είναι αυτό. Ο καθένας, τώρα βλέπεις εδώ, τώρα σε αυτό το item με τους Ουσμπέκους και με αυτά, δεν βρίσκεις άκρη. Έτσι που είναι η κατάσταση, εγώ δεν βρίσκω άκρη.
Ναι.
Δηλαδή, μην νομίζεις και οι Εβραίοι το minimum. Το minimum θα κάνουν και θα σου ζαλίσουν στο negotiation. Βέβαια, αυτοί όταν κάνουν μπλακούν έχουν και ένα επίπεδο. Αλλά μετά οι άλλοι κακομοίριδες δεν καταλαβαίνουν. Δεν τους βλέπεις εδώ. Αυτό το ΚΑΕ, δεν ξέρω από και το πανεπιστήμιο το Καρσί. Αλλά ο τύπος δεν είναι. Δεν πρόκειται να. Γι' αυτό και το δεύτερο installment, καλά που με πονηρέψανε από το οικονομικό, δεν τους αφήνω φράγκο. Μετά δεν γυρίζουν λεφτά.
Ναι, όχι, αυτό σου είπε, δεν σου είπα. Πολύ καλά το σκέφτηκε η Πόπη, πάρα πολύ καλά.
Να δούμε τώρα τι θα γίνει, γιατί άμα είναι έτσι κατάσταση, γίνονται πολύ δύσκολα τα πράγματα. Εντάξει, είπες ένα μήνα να πάει, αλλά να πάει τώρα αυτό να γίνει πώς θα το πω, να είναι συστηματικό και να διαρκέσει τόσο καιρό, εντάξει, είναι κουραστικό. Δηλαδή, εσύ πώς το συντηρείς και εσύ, με webinar και τέτοια?
Κοίταξε, εμείς τώρα στο project που έχουμε, το ένα, κάνουμε events ο καθένας στο πανεπιστήμιό του. Οπότε αυτά γίνονται. Άλλοι τα κάνουν online, άλλοι φυσικά.
Εγώ έχω παράδειγμα στο Κρήτ, το Thomas Moore. Το Thomas Moore είναι τελείως άφαντη.
Ναι.
Δηλαδή, έχουν αρρωστήσει και οι δύο. Οι δύο αρρωστήσανε.
Ναι,
μετά
αρρώστησε η Φέδρα, μετά αρρώστησε αυτός ο Πάτρης.
Η Βαρσοβία είναι πολύ ελιτιστές και θέλουν συγκεκριμένα πράγματα και αν τα... Ενώ ήταν καλή partner αυτή, δηλαδή, αλλά είχαμε πιο τεχνικά θέματα μαζί τους. Δηλαδή,
ναι, μάλλον.
πολύ well focused στη φυσική και στο... Τέλος πάντων, θα τα πράγματα, αλλά σου αλλάζουν την Παναγία. Δηλαδή, δεν αξίζει τώρα αυτό το πράγμα.
Δεν, όχι. Δεν, και εγώ δεν ξέρω τώρα. Εμένα φεύγει και αυτή που είχα, η research assistant, μου είπε χθες.
Που είχε στο item που είχε μια κοπελίτσα αυτή.
Ναι, μια Ελάισσα, την οποία την...
Στο Κρήτ.
Ναι, και στο Κρήτ. Όχι την Κριστή, όχι, αυτή έχει φύγει ήδη. Μια άλλη που την είχα στο Ίνος και με βοηθάει γενικότερα σε ό,τι μπορεί η γυναίκα. Αλλά αυτή τέλειωνε το συμβόλαιο της τον Οκτώβριο και εγώ δεν είχα αρχικά λεφτά. Τώρα ήρθαν 2 project που ουσιαστικά άλλοι τα κατέβασαν. Σου λέω, εγώ είδα φως και μπήκα, δηλαδή.
Εντάξει, καλό είναι αυτό.
Ναι, και τελικά πέρασαν. Και, το ένα ήταν αυτό με τον Ρικάρτο, αυτό που είμαστε μαζί, το Agile. Και το άλλο ήταν ένα με το Εκετά, που το κατεβάσαμε εδώ, το γράψαν αυτοί. Οπότε πέρασαν αυτά τα δύο και τις ήρθα στο ανοίξω ποστό.
Εσύ, Ευαγγελία, θα σας ρωτήσω, το Εκετά, τι είναι αυτό το πράγμα? Όλοι κάνουν project με το Εκετά. Τι είναι το Εκετά? Το ακούω Εκετά. Τι στο διάλογο είναι αυτό?
Το Εκετά είναι ερευνητικό κέντρο και έχει διάφορα Ινστιτούτα. Έχει διάφορα, έχει, ξέρω εγώ, εμείς ξέρω το ITI, τι λεγόταν παλιά, που είναι το Ινστιτούτο τηλεματικής και Ινστιτούτο Πληροφορικής και Τηλεματικής λεγόταν παλιά. Και εκεί δούλευε ο Γιώργος, η ερευνητής, εκεί δούλεψα και εγώ πριν φύγω Ολλανδία. Και τώρα ξέρουμε, πολύ κόσμο, εντάξει, είναι και φίλοι μας και αυτά. Αυτοί κάνουν πολλά έτσι με machine learning, agents, έχουν διάφορα με ό,τι έχει να κάνει με τεχνολογία. Είναι καλοί partners, έχουν πάρα πολλά project, Horizon.
Και στείλε μου να δω, και εγώ ακούω κοιτάει. Κάνα τίποτα, όχι. Είπα, τελευταίο ήταν αυτό με τα μαθηματικά γιατί με πιέσανε με τους άλλους. Αλλά δεν ξανακατεβάζω. Τώρα θέλουν κάτι Γερμανία από το Αθηνά να κατεβάσουμε μου. Τους λέω σιγά μην κάτσω εγώ σε ένα μήνα, θα μου βγει, καταρχήν δεν βγαίνει. Και δεν θέλω να έχω χρόνο. Δεν έχω χρόνο με τη γυναίκα μου. Θα κάτσω εγώ. Λέει, μπορεί να το είπα σαν ιδέα. Λέω, είπα την ιδέα, κάτσε, το κάνει και κάποιος. Τώρα δεν μπορώ, περιμένετε. Άμα θέλετε, περιμένετε. Τι με νοιάζει εμένα. Δεν έχω ανάγκη.
Ή ας τη γράψουν μόνοι τους. Άμα αυτοί
αφού θέλουν, ναι. Γράφετε και θα το κάνω coordinate. Γράφτε το όμως.
Ναι.
Είναι και οι Ευρωπαίοι, είναι μαμούνες. Δεν είμαστε δηλαδή τώρα. Παλιότερα έλεγα ότι εμείς είμαστε πονηροί, αλλά έχει στην Ευρώπη πολύ πράγμα.
Όχι, δεν έχει να κάνει. Είναι ο άνθρωπος μου, εντάξει, δεν ξέρω.
Εσύ πότε θα ξέρεις τώρα και μετά τι επιλογές έχεις, εσύ, Ευαγγελία? Δηλαδή πες, εγώ σου εύχομαι να σε κρατήσουν, έτσι.
Καλά, να σου πω την αλήθεια, δεν ξέρω κι εγώ αν θέλω να με κρατήσουν. Κοίταξε τώρα, έχω κάνει αιτήσεις σε πανεπιστήμια, μέχρι τώρα βέβαια δεν με έχουν πάρει και πουθενά. Τώρα είναι μια θέση μέχρι το Μάιο θέλω να κάνω στο Πολυτεχνείο εδώ. Μετά, τώρα κάνω certification σε Scrum και σε ένα άλλο, Prince 2 λέγεται.
Θέλω να στείλω ένα διδακτορικό μου για το Scrum. 1.000 ευρώ είναι, πόσα είναι, 1.500 ευρώ, πόσα είναι το...
Τόσο πρέπει να είναι, ναι, τόσο είναι.
Δείτε μου το πρόγραμμα, το γράφω, το λουράκι θέλω να στείλω, ένα διδακτορικό που έχω και το δοκιμάζουμε το Scrum τώρα.
Μας το κάνει αυτό, πώς είχαμε παλιά το Τσμέδε για τους μηχανικούς. Το κάνουν αυτοί. Δηλαδή δίνουν Scrum Certification, ναι. Αλλά δηλαδή πρέπει να βρεις κάποιον, θα έχει σίγουρα στην Ελλάδα κάποιον.
Άμα έχουμε απορία, μπορούμε να σε ρωτήσουμε, είσαι και εσύ στην τριμελή αυτού του λουράκι.
Ναι, μα σου έχω πει και είχαμε κυρώσει και να μην την πω.
Το κάνουμε εμείς, το κάνουμε στον ηλεκτρομαγνητισμό και δουλεύει πάρα πολύ καλά. Δηλαδή, φανταστείς τώρα, εσύ ξέρεις τώρα και από τον άντρα σου. Δεν ξέρω αν είχες κάνει μάθημα στο ΤΕΙ. Έτσι τα παιδιά.
Είχα κάνει.
Όχι η παρουσίαση τους κάνουν, δηλαδή, αλλά αυτό είναι και το challenge όμως, είναι και το όμορφο. Και τώρα τους βλέπεις και κάνουν παρουσιάσεις, πώς δουλεύουν, πώς συνεργάζονται και σε αυτά, σε ένα μάθημα που εμένα περνάει το 3% περνάει. Έτσι, και τους χαίρομαι. Πραγματικά, δεν κάνω τίποτα, κάθομαι και τους ακούω, πώς μιλήσανε, πώς αναλύουν και είναι πολύ ωραία μέθοδος. Βέβαια, έχω μπερδευτεί λίγο τι διαφέρει από το BBL και το λέω στο Λουράκι, μου λέει όχι, λέει, στο BBL είναι πιο well-defined, εδώ πέρα είναι ούτε υπάρχει ο leader, είναι όλη μια ομάδα και μιλάνε και κάνουν. Παίρνει και ο Λουράκης ήταν σμηναγός στα F16, είχε φτάσει. Και τώρα πήρε σύνταξη και ασχολείται και είναι πάρα πολύ καλό. Ξέρεις ότι θα βγάλουμε σίγουρα δουλειά με αυτόν.
Ωραία, ωραία. Αυτό είναι σημαντικό. Ναι, ό,τι θέλετε, εγώ κάνω αυτό τώρα, κάνω και ένα άλλο, γιατί σκέφτομαι ότι αν βγω, για να βγω έξω, πρέπει να έχω ένα certification, γιατί τώρα με management στο πανεπιστήμιο δεν πείχε. Σου λέει, ήσουν ακαδημαϊκός τώρα, τι μας λες. Αλλά τέλος πάντων είπα να κάνω και αυτό και βλέπουμε. Δεν ξέρω, είμαι σε μια φάση αναζήτησης, δεν ξέρω τι θέλω να κάνω.
Βλέπω πεσμένη δηλαδή ψυχολογικά.
Όχι μωρέ πεσμένη, σκεφτική, δηλαδή το σκέφτομαι, γιατί λέω ακόμη και να μου βγει η θέση, εντάξει, θα την κρατήσω σαν plan B, δεν το παίζω άνετη, δεν τη χρειάζομαι, αλλά παράλληλα θέλω να σκεφτώ. Ναι, θέλω σίγουρα, δηλαδή είναι αυτό που θέλω να κάνω τελικά, γιατί είμαι και σε μια κρίσιμη ηλικία, ξέρεις.
Εγώ την έχω περάσει, επομένως δεν με νοιάζει.
Αν είναι να κάνω μια αλλαγή, ρε παιδί μου, να την κάνω τώρα, κατάλαβες, εντάξει.
Το consulting δεν θες να πας, θα σε βοηθήσει πολύ όλο σου το background από το BBL, θα σε βοηθήσει πάρα πολύ στο consulting. Βέβαια η ζωή σου θα είναι πολύ απαιτητική έτσι μετά, δηλαδή εσύ και την οικογένεια πρέπει να σκεφτείς. Το consulting θα ταξιδεύει συνέχεια, θα είσαι στην πίεση συνέχεια, αλλά νομίζω αυτό που έχεις με το BBL είναι το νούμερο 1. Δεν θα έχεις πρόβλημα.
Ναι.
Hi, Adrian.
Hi, Pana Kostas.
You just placed two of us, and we're discussing gossiping.
Now, this is a problem. I was trusting you, Kostas, that you're not disturbing Eva, because if I put Eva alone, Eva would have solved the problem.
All right. Thank you.
And this is your role in this business, to bring in confusion. So, Eva, can you please try ignore your discussion partners, do not share with him any slide, and really try to do the problem, because we need your feedback also scientifically. Forget about Kostas for a moment, mute your phone.
I cannot forget about Kostas.
Let him talk, but mute him. I can mute. Can I mute him? I can't mute him.
I can realize. I mean, you know, from my experience interacting with people, I have met a lot of people like Adrian that they cannot realize, you know, what I do. But you know,
I can tell you.
That's why I'm very empathic. I demonstrate empathy to the others.
Yeah,
these are the people.
I have to disagree with you, Kostas, before leaving the room. You didn't meet many people like Adrian. It's more you are going to see in the coming years. Say 18 months you want to stay together. It's more is going to happen. I leave the room. Have fun.
Bye. Bye.
Eva, I'm looking for your solution. Don't write Greece, just write Eva. It's okay.
Let's solve it. Let's solve it because now you challenge me. Τι ήθελα να σου πω, ναι.
Για το consulting, καλά, δεν ξέρω, θα δω.
Κάνε το consulting οπωσδήποτε. Νομίζω ότι αυτό θα είναι το νούμερο 1 που θα σε πάρουν. Καταρχήν θα περάσει το interview, γιατί το interview όλα αυτά είναι. Δηλαδή, δες τη Motion Consulting, παίρνουν συνέχεια ανθρώπους, που είναι η καλύτερη εταιρεία. Δηλαδή, η γυναίκα μου είχε φτάσει partner και εντάξει, μετά πήγε κάπου αλλού γιατί ένας εφοπλιστής έκανε καλύτερη προσφορά. Αλλά ξέρεις, βλέποντας το BBL και όλο αυτό, λέω, αυτό είναι που θέλουν αυτοί. Δηλαδή, άμα θέλεις αυτά τα soft skills που θέλουν τους φοιτητές, είναι πώς τους διδάσκεις. Άμα τους έχεις σαν χάνους και λες εσύ και ούτε κάνεις interact, ούτε λες έτοιμα, χάνοι θα μείνουνε. Χάνος θα είσαι και εσύ βασικά, γιατί είναι άλλο να έχεις και κάποιους που να ρωτάνε από κάτω και να σε έχουν στην πίεση.
Σίγουρα. Θα δούμε.
Λοιπόν, έλα να κάνουμε αυτή τη μαλακία, μην τον έχω το Ρουμάνο και...
Εγώ δεν ήμουνα, δεν είδα καν το πρόβλημα.
Καλύτερα. Να μου πει ο Ρουμάνος εμένα βλάκας.
Μ' αρέσει που λέει την Εύα, λέει την αποδιαργανώνεις. Η Εύα δεν ξέρει ούτε καν το πρόβλημα.
Εγώ κάθομαι εδώ πέρα. Βαριέμαι τώρα εγώ. Κάτσε να το βρω.
Ναι, είδα φως και μπήκα. Δεν το είδα γιατί δεν είχα ίντερνετ.
Εγώ ξεκίνησα με τους άλλους, είχα τους μηχανικούς εκεί πέρα. Είχα πιάσει το Βαγγελάκι, του λέω Βαγγελάκι, ή θα το λύσεις, θα σε διώξω. Άλλος αυτός, μαλάκα τίποτα. Έχει τη σύμβασή του και κάθεται, δεν τον πληρώνω. Του λέω, εσύ θα κάνεις κάτι, τίποτα.
Τι να κάνει κι αυτός.
Λέξη μου είναι.
Εντάξει, για το Crete όμως το έκανε το 5G.
Ποιο έκανε, ρε. Ακόμα δεν έχει κάνει τα self-evaluation. Μου είχε αλλάξει την Παναγία. Πριν 2 Σεπτέμβρια. Before 2 September.
Δεν το ήξερα. Νόμιζα το είδα εγώ ότι είχε υλικό. Λέω, εντάξει, το έχει τελειώσει.
Άσε, είναι δράμα. Πρέπει να προσέξεις πάρα πολύ όταν γράφεις τα deliverable. Πρέπει να είσαι σίγουρος ότι...
Ναι. Αυτά είναι αυτό που λες τα λάθη που you learn the hard way. Το έχω κάνει και εγώ.
Θα το μάθεις. Το hard way θα το μάθεις όταν έρθει το evaluation, εκεί θα το μάθεις. Αλλά εντάξει, βγήκανε μωρέ, εντάξει, έχει βγει, δεν είναι κάτι... Το Crete έχει βγει, κάνουμε και τα webinar, τι άλλο να κάνουμε.
Ναι, όχι, μια χαρά. Στο Crete, εντάξει, τελειώνει λογικά, τελειώνει, μια χαρά αυτό, ναι.
Το item να δούμε. Το κάνουνε λίγο πολύ.
Ναι, μωρέ Κώστα, τώρα κι εσύ, εντάξει, όσο... Και μόνο που πήγανε και ακούσανε ένα webinar, ήρθανε στην Κοπενχάγη. Εγώ να σου πω, πιο πολύ νομίζω είναι αν μπορέσουν να φέρουμε κανένα student εδώ, να κάνουν ένα ταξίδι, κανένα καθηγητή, δεν πειράζει. Ακόμα και αυτό είναι καλό για αυτούς. Μια άλλη εμπειρία, λες, εντάξει, παίρνουν τα λεφτά, εντάξει. Μπορεί από το ένα να μπαίνουν, από το άλλο να βγαίνουν, αλλά δεν βαριέσαι. Είναι και το cultural, ρε παιδί μου, και το τέτοιο. Κάτι θα δούνε, κάτι θα τους κάνει εντύπωση, κάτι μπορεί να κάνουν. Εντάξει, είναι αγχώνες. Δεν βαριέσαι.
Εγώ κάνω ό,τι μπορώ. Τώρα, ό,τι έγινε, έγινε. Τι να τους κάνω.
Ναι, όχι. Εσύ όχι μόνο ότι μπορείς και με το παραπάνω.
Ναι, αλλά τώρα, άμα έχεις την ευθύνη, ξέρεις, στριβογυρίζεις λίγο το βράδυ και λες τώρα και τι θα κάνω. Τώρα έχω ένα meeting για ένα άλλο, το iPad, που είναι στη φωτονική συναδελφολογία. Και δεν ξέρω, έχω κουραστεί πλέον να τους λέω τα ίδια. Δηλαδή πρέπει να το τελειώσουμε αυτό, πρέπει να το τελειώσουμε αυτό. Έχω κουραστεί, δηλαδή δεν έχω... Και εν τω μεταξύ, τους έχω μάθει, εγώ φταίω σε αυτό. Ότι ξέρουν ότι αν δεν το κάνουν, θα το κάνω εγώ. Αλλά μετά δεν έχεις ενέργεια κι εσύ, δεν έχει φύγει η ενέργεια.
Όχι, δεν πάει έτσι. Εγώ αυτά τα έχω σταματήσει. Όποιος δεν κάνει, κάποιοι έπρεπε να στείλουν κάτι μέχρι την προηγούμενη Παρασκευή, δεν το στείλανε. Τους έστειλε ένα reminder τη Δευτέρα, ένα εχθές, σήμερα το ανεβάσανε. Γιατί εγώ θα καθίσω να το κάνω. Δεν υπάρχει περίπτωση. Θα στέλνω reminder. Μέχρι να το κάνουν. Δεν το κάνουνε. Ας μην το κάνουνε, ας μας κόψουν και τα λεφτά. Μήπως εγώ θα τα πάρω. Εγώ τα παίρνω. Ούτε εγώ τα παίρνω. Εμένα το πανεπιστήμιο, το καλό που έχει είναι ότι κάνει πρόσληψη, τα πληρώνει αυτό και μετά παίρνει τα λεφτά από το project. Ναι. Οπότε στη χειρότερη θα βγουν αυτοί μείον. Και εμένα τι με νοιάζει, μήπως εμένα με πληρώνουν. Εμένα δεν με πληρώνουν. Εγώ δεν παίρνω δραχμή στο χέρι. Τίποτα. 0.
Σε κάνουν απαλλαγή τίποτα από το teaching ή...
Όχι, δεν μου κάνουν. Γιατί πρέπει, για να καλύψω εγώ τον εαυτό μου, θέλω 2 project γιατί, ξέρεις, τα rates και αυτά είναι τέτοιο. Δεν είναι εύκολο να καλύψω το δικό μου το μισθό. Και γι' αυτό βάζω ελάχιστες ώρες. Γιατί λέω, γιατί να χαλάσω τις ώρες, ας πάρω τουλάχιστον ένα να με βοηθάει. Σου λέω, τώρα φεύγει κι αυτή. Και δεν ξέρω τι θα κάνω. Θα δώσω καμιά πέτρα στο λαιμό μου. Αλλά το σκέφτηκα κι αυτό.
Ποιο, να βάζω consulting?
Όχι, το σκέφτηκα να τους πω ότι για το επόμενο χρόνο ή εξάμηνο, όσο φτάνουν τα λεφτά και χρόνο θα φτάσουν, ότι θα κάνω μόνο project. Δεν θα ασχοληθώ με τίποτα άλλο.
Άμα σου δίνουν αυτή την επιλογή, σου δίνουνε. Αλλά δεν είναι
safe.
Ξέρω, και να στο πούνε αυτό. Αυτό δεν είναι safe για σένα. Δηλαδή μετά που θα τελειώσουν, να σου πούνε, τους δίνεις το δικαίωμα να σου πούνε, τελειώσαν τα λεφτά, γεια σου.
Αυτό ακριβώς. Ιδίως τώρα να βγάλουν θέση, θα τη βγάλουν γιατί φεύγει πολλοί κόσμος και θέλουν να καλύψουν κενά. Αν τους πω εγώ φεύγω.
Φεύγει κόσμος.
Ναι.
Γιατί και πού πάνε?
Τους διώχνουν.
Τους διώχνουνε.
Τους διώχνουνε.
Όχου.
Ναι.
Και πού πάνε? Δηλαδή κάτι Έλληνες, πώς το λέγανε ένα άλλο παιδί που ήσουν εσύ
ο Λάζαρος.
We had a discussion. Why did you stop us? You stop our discussion.
We stopped it.
You stopped us. We
So
are
you're all back
Yeah.
now.
This is your excuse of saying problem was nearly solved, but I couldn't press the button because I remember while I was a child, I was saying I did my homework, but my dog has eaten it and then I couldn't deliver it. It's very similar, Kostas. We know these things.
exactly.
So,
You're
I
too
g-
Romanian. Too Romanian.
yeah, we recorded your solutions. And we are worried about the situation with roller coasters a little bit, but my colleagues will talk to you now. Okay, I stop talking. Mute myself.
Okay.
So I think there might be people left in breakout rooms, so we have to end.
Do you think
all.
so?
Is it? Because I can see people in some breakout rooms. yeah.
Okay. Then we have to.
It takes some time. It takes 1 minute for the rest of the people to return.
Okay.
Yeah.
I hope we can welcome everyone now back in the main room.
Testing.
But there's,
That's interesting. Nicht begonnen.
for example,
Oh.
Kosovo 3.
I'll take back all of them.
No, I cannot.
I can do it.
Yes, that would be great if you can.
Are there still people in breakout rooms?
It seems.
I'm not sure, but
Have you, Renata? Can you send a message? Broadcast to the rooms.
It's always the thing. Those who are not here, they should tell us that they are not here. Please tell us that you are not here. Please raise hand those who are not here so that we can go on. I think we can go on.
Okay.
I'm so confused, but I think all of them verschieben, austauschen, array, they're back.
Okay. Yeah. Yeah.
Okay. So we are
We
very
can-
sorry for the problems for some of you to open this link and work on the problem. We had also problems here, so but we will now talk a little bit about possible solutions to this task. And of course, you have needed much more time to work on these tasks, but we will talk about it and show some solutions. So, of course, the first thing is to put it in a coordinate system, which could be done in different ways, but this is probably the most usual way to do it. And then we have certain conditions that should be fulfilled. So we know that the function value when x equals 0 is 0, and when x equals 10, it's 15. And we also want the derivative to be 0 at these 2 points. So that's what we have to work with. So I think that's the 2 first steps. And then the third step would be to decide what type of function should we try to use in this case. And most of you, I think, have tried polynomial functions, and that's one good option. We could also think perhaps of a trigonometric function. So if we try a trigonometric function, we have to decide these values for the amplitude, the shift in the x and y direction, and also the constant beta. And we want to have this graph then. So we have to decide the amplitude and the other things. And the amplitude must be 15 divided by 2, 7.5. And the shift in the x direction is 5. So the value of alpha must be -5 then to get a shift in the x direction. And then we want to have a shift in the positive y direction by 7.5. And then we have to calculate beta, and we see that one period in this example will be 20. So then we can decide the value of beta. So this would be one example of a solution, or written in another way, this function. And of course, a trigonometric function also could be a cosine function, and it will look a little bit different in the formula, but it will be, of course, the same function. So that's the first solution. Another possible solution. Oh, I also have the generalization. If you don't have 10 and 15 meters, you have A and B instead. And it's not so hard to make a more general solution. So we don't have to look in it in detail. We can have these slides on the website, so you can look at it if you want to. So the next try perhaps would be a polynomial function. Perhaps this one, a third-degree function. And we have to use these things again. But now we know that we want the derivative to be 0 when x equals 0 and when x equals 10. So perhaps the easiest way is to start with the derivative and say that it should look something like this, a constant times x minus 10. And then work on from this. So if we have the derivative, we also can have the function, take the primitive function, and then we can decide these values of alpha and beta by using the 2 points that we have. And in this way, we can come up with the formula. So this is a third-degree formula that fulfills the conditions. And also this one, of course, can be generalized. So I just show it very quickly, but it's you can almost see it from the figures in the examples with 10 and 15. So it's not so hard to generalize the solutions. So I think these two are the most common. We have used this at our education, and many students came up with these two functions. If you should look for more unique functions, perhaps you can try a piecewise defined function. Perhaps use 2 second-degree functions like this. So you have the blue one, and then you have to mirror this one and translate it, shift it to get the red one. So it's rather easy to get the blue one. It's a constant times x squared. And then you just have to decide the constant with 1 point, the point 7.5, 5.7.5. So we have this blue function. And the red function, we have to do a reflection of the blue one. So we will have minus 0.3 x squared instead. But then we also need to have a shift in the x direction and in the y direction. So it will be this function, minus because we have reflection, and then minus 10 because the shift in the X direction, and plus 15 because of the shift in the Y direction. So the solution will be like this. Perhaps we don't want to have X squared. Perhaps we want, oh, I skipped this generalization. Perhaps we want to have X to the power of some value that we can change to get different slope on the curve. And it will be very similar to the case with the X square solution. So we can have something like this. So instead of alpha X squared, we have alpha X to the power of C. And as I said, it will be a very similar solution. First, we decide the value of alpha, and then we do the reflection and the shift in the X and Y directions. So we don't look at it in detail, but this is the red curve that we have, and this is then the solution. But all these solutions, they have their maximum slope when X equals 5. Perhaps we want to have a solution with the maximum slope when X equals 7 instead. How should we fix that? Well, perhaps a curve that looks like this, a 4th degree polynomial function. But then we have to start in this way. The graph should have an inflection point at X equals 7 then. And then we know that the second derivative in 7 should be 0. And then we can start from there and construct our function. So it must look something like this: a constant times X minus 7 times X minus something else, some value. And we have to decide these two values. And there will be some work to do, but not too hard. We have everything that we need to solve this from the Calculus 1 course. So at the end, we will end up with the solution you can see at the bottom here. That's the formula for the function you can see in the graph. So these are some different solutions to this problem. And of course, if we have this in a class, we have to have lots of time to work on this, but everything you need, you have in the calculus course. So just a few slides more. Why is this a good task in our opinion? Because we think it's a good task, but of course you need to have much time to work on it, as I said before. Well, the first thing is it's an open-ended modeling task. And that means that it allows for multiple solutions. And because it allows for multiple solutions, it also promotes communication and reasoning, two very important competencies in mathematics. And it also can be individualization within the task, because if you find one function, you can look for the next, and you can try to find more advanced functions. So in this way, there will be individualization within the task. It's also a special type of task. It's called example generating task. It's used a lot in mathematics education. It's a lot written about this kind of task. This kind of tasks, it will often be more focused on conceptual understanding than on procedural knowledge. So lots of people have written about this. Two people, Anne Watson and John Mason, very famous mathematics education people, for instance, have written a lot about this. I will just give you one example to show you more what I mean. If we compare the following tasks for elementary school, calculate the area of a rectangle with side lengths 4 centimeters and 3 centimeters. That's usually how the tasks look. Procedural knowledge. You can solve this task without knowing so much about area, for instance. But if you make it an example generating task, it will be more focused on conceptual understanding. Give 2 different examples of rectangles with the area 12 centimeters. It will be a completely different kind of task. Or how many different examples can you find? Or try to come up with an example that you think is unique in the classroom. Or perhaps try to come up with an example that you think is unique in the world. That should be possible. So, 2 more points about why it's a good task, in our opinion. So many concepts from the first calculus course come into play, of course. Depending on what the solution you choose, it will be different concepts from the calculus course. And the dynamic software can be used to test and modify your conjectures. When you think you have a solution, you can try it on the computer. And the good thing is that if the suggested function do not fulfill the requirements, the response from the software often provides information that could be used in a productive way. You can think of how do we need to change the formula so that the graph fulfills the conditions. Perhaps it's just to divide everything by 2 or something. You can, depending on what the graph looks like. And the last and perhaps most important point, it is a task that encourages creativity. If you listened yesterday to Ronnie's talk, many features of the task that enhance creativity highlighted in her talk, very nice talk yesterday, fits well into this task. It's an open-ended task. It allows multiple solutions and multiple representations. It allows different approaches, builds on reversed thinking. It requires students to exemplify and generalize, and it encourages students to originality. So that's why we think it's a good task. But sorry for giving you so little time to work on it.
And here we stop.
I would say that this was an excellent example of how we can apply fundamentals.
Thank you. Perhaps there are questions, or is it now time for a question session, or?
Yes, of course. There's a time for question session. Yes, thank you very much for, yes, it was a very interactive session. And I think all of them, they participate in the breakout rooms. They enjoyed it, I think so. Yes, questions, please. Now we have the experts here with working with example on GeoGebra.
Can I ask something myself?
Yes, please.
So, I mean, how do you create a pool of exams? I mean, it's like the educators that you create a pool of exams. So before the semester will start, you have something like tailored to each section. Like, how do you work in Karlsland on this? Like, I mean, this was an example that you can apply, for example, in functions. If we go, it contains also integrals and differentiation and this kind of operation. But how do you build the pool of the examples that you are going to use before the semester starts?
I'm not sure that I understand. Did you say that I have problems with the sound?
No,
I think I mean, it's about, do we have a pool of such examples?
Yes,
For
exactly.
all courses, for all topics?
Okay. No, we don't have that, but we are working on a project where we are constructing, designing tasks for the first year engineering students that they work on, and they use both the dynamic software GeoGebra and a computer assessment system. In our case, Möbius, but it could be, of course, Stack as well. So we are trying to produce tasks that will promote mathematical understanding, and that, of course, has been a problem with these systems that can correct students' work automatically, that it often has been more focus on procedural fluency tasks. But by using also GeoGebra, we try to create tasks that promote more mathematical understanding. And one type of task that we use a lot is this type called example generating tasks. So for instance, we have give two examples of a rational function with horizontal asymptote y equals 2 and two horizontal and two vertical asymptotes x equals -5 and x equals 4 or something. Try to shift the tasks so it's not that much calculate this and this, more give examples of different functions, for instance, fulfilling certain conditions. And also we have tasks where we try to, instead of construct a graph, they get graphs that they should find the function formula for. And that's often much harder to go in that direction. So that's one typical kind of task that we use in this activity.
So you try to interconnect, you know, the three parameters that describe, for example, a function. Like you are giving the graph in order to construct the formula, or you are giving the measurements in order to construct the formula and the graph. So you are playing around this kind, let's say, of triangle.
Yes. And also we have some tasks where they should explore something in GeoGebra and discuss in groups, and then try to formulate what they have experienced. But of course, that's tasks that are hard to correct automatically in Stack or Möbius. But these are the three main types of tasks that we have used in this project. But we have just started the project. We have applied for money for it, so we will see what happens.
And the data that you are they are generated to you can be you know, they can come from research laboratory. So a research laboratory can provide you, you know, some set of data, and you can work on them for the students in order to create the formula or to generate the graph. Are you using this kind of data, or are you using, like Rodrigo yesterday, data that they can be found on the internet?
Kostas, the problems are conceptual, difficult. It doesn't make sense to make it even more difficult. Real life data is usually not so nice. It's usually ugly.
Okay, all right, okay, yes. So we can use, for example, you know, data that they are coming from physics, like from electronics or stuff like this.
Yes,
like,
absolutely.
More straightforward, okay.
Yes, we haven't done that yet, but of course that could be a good idea.
Thank you, thank you.
Other questions than Kostas?
No. Yes, are there further questions? I think all of them are very tired. Okay. If it's not
I just want to say that it was a very good exercise, and that if it's okay, I will borrow the idea and adopt it in my class. So thank you very much.
Of course, of course.
But this was the purpose of the workshop, no?
Yeah.
Take these ideas and use them. Otherwise, we can
Yeah. We can say one interesting thing when we have used this task with our students is when they should provide two different functions. Many students have provided the same function, but written in different ways. So they have provided two trigonometric functions, one in a sine, as a sine function, and one as a cosine function, and they don't realize that it's really the same function. And also some students, I guess they have realized that it's the same function, but the second one they have perhaps just multiplied by 2 and then divided by 2 to get a different formula. But we think it's a good idea that they should provide not just one example, but 2 examples.
So yeah, because as you said before, it's or you had in your presentation, it's a good connection to the presentation yesterday from Ronnie. So
yes, we were very happy about her presentation yesterday.
Yeah. So yeah, I think it was a very successful to work. So Kostas, what do you say?
I would think that it was also replied to Ronnie's, let's say, because Ronnie mentioned, like, my expertise is on the high school, but this example also showed that whatever Ronnie presented is directly applied to the higher education, like using the example from the colleagues from Carlsen. I think this is like excellent. Like if we combine these two, shows how we should work.
Yeah.
Okay, so from my side, I think we.
And also, can I mention something else? also showed that we are making a mistake by isolating mathematics from the core specialization courses, because you can learn mathematics like using this kind of exam through the specialization courses. All right. So, I mean, if you're an engineer, let's say, and design, bridges, like I don't know what else, or rolls coasters, with this exam that you mentioned, you can understand and you can realize, the functions, the properties of the functions. How can you move from the sine to cosine? It is like, I think that this is a mistake that we are doing. We have, mathematics and physics as well, like isolated courses at the beginning, and the people that are still wondering, what's happening. This is like what I'm getting. All right.
So
also we should.
Because would you like to close the session?
We have to close. We have a quarter.
and end up with some nice words.
which is me? All right. We should close now. Okay, this is a hard moment. Whenever you are closing, it's like a hard moment because you spend so much time with these people. So I would like to thank all the participants on behalf of the item, not on behalf of me, but on behalf of the item. Personally, I mean, this was not so difficult. I learned a lot of things that I will keep during my lectures from all the speakers. I would like to thank the speakers again for their contribution, because this comes on the volunteer base, and also the attendees. We are going to design more such things within the item project until we are going to stabilize and be able to run, these events face to face. I don't have anything else to say, but thanks to everyone, speakers and participants. It was a very nice 2 days, and I will keep the note of Adrian that we should make more breaks in order to not be unhuman. All right, this is something that I should keep on my mind. All right.
Thank you, Kostas.
Thank you very much. Bye, and have a nice
day.
Bye-bye. Thank you.
Thank you.
Bye-bye. Bye-bye.
Please send us the presentations in order for me to sit down and update the site and place all the material through our website. Okay.
All right. Bye-bye.
Bye-bye.
Bye.